I can't hear it.
There we go.
Okay. Ladies and gentlemen, my name is Richard Soley. I'm Chairman and CEO of the Object Management Group and Executive Director of the Industrial Internet Consortium. Thank you for joining us today for a short but fascinating program on building intelligent infrastructures. We are absolutely delighted to have been working with the RIoT, when you're going to hear from our co-event partner in just a moment. They've been a tremendous partner, and we're super excited to be working with them, and we're looking for ways to work with them in the future as well. And we want to thank SAS Institute for hosting the event. Also been tremendously wonderful to work with. And it's a great facility, I think you'll agree with me. And farms nearby, that's all we really cared. Nobody's got a sense of humor, okay. We have a great program today, and we'd like you to participate. So please join in, interrupt, ask questions, see what you can learn, see what we can learn. The Industrial Internet Consortium has been around for 5 years, almost exactly now, and focusing on building test beds in industrial internet test beds in manufacturing and production, agriculture, healthcare, smart cities, and smart infrastructure like smart buildings. And we're learning a lot about how to build industrial IoT systems by actually doing it. And it's by working with groups such as RIoT that we learn a lot about how to do that and how to do it all over the world. Speaking of RIoT.
Cool. Thank you, Richard. So I'm Tom Schneider. I know, see some familiar faces here in the room and a lot of folks that I haven't met, so I look forward to meeting people today. It's been wonderful partnering with IIC on this event. I think we have a lot of shared values. We're both interested, and I hope all of you are interested in growth of the IoT sector broadly. We are also industry agnostic. We're geography agnostic. We're building a center of excellence here in North Carolina towards IoT, but it's really to serve the market broadly. So if you're not engaged in our community, we'd love to meet you. We'd love to have you join our events. I hope that this is not the last time that we do something with IIC.
Not the first.
That's right. It is the first. I want to give a couple of just quick thank yous. Today's agenda really has been pulled together by a team of folks, but Michelle and Brad at SAS have been instrumental in pulling that together. Cheryl and Kathy and the whole team at IIC. I'd like to thank Caroline and Sarah on my team. We've done a whole lot of work. We'll make sure that everybody gets to meet them. Who here, this is your first time at an IIC event? Fantastic. Really, really glad to have you out. This is an incredible organization. I think you'll see by the end of the day that if you're not a member already, you need to join Richard's organization as well, and we'll push this industry forward together. So without further ado, though, let's go ahead and get started.
So to introduce us, we've got Kathy Walsh from the Industrial Internet Consortium, and while Diab made it just in time, Secretary of the Industrial Internet Consortium's steering committee, and also with Huawei. Please.
Wow, this is a great facility. Thank you very much, and thank you for the nice introduction, Richard. So Kathy and I actually chair the Global Event Series Task Group, which is what puts these things on. So the first thing I wanted to say is just thank you to SAS and thank you to the staff for pulling this together. So the Global Event Series is a program where we basically try to take the industrial IoT message, which is a global message, and push it out through partnerships at the regional level like we're doing today. And that was great, the question that you had asked about how many people are new to IIC, because that's exactly the point. In part, what we try to do is, through these series of events, help accelerate the adoption of industrial IoT, provide for thought leadership, also help educate what we are doing inside of IIC, and hopefully get you to engage with us. So we'll be here throughout the day. There's a number of people that will be speaking, as well as folks that are involved in various aspects of IIC that you can talk to us throughout the day.
Thanks, Wael. Again, I'm Kathy Walsh. I'm the Vice President of Marketing for the Industrial Internet Consortium. I'm honored to be here. Very glad to see everyone. I hope I get a chance to meet a lot of the new faces that I haven't met yet. I just wanted to expand on what Wael said. We started this public-facing event series with a focus on manufacturing. And at that time, we partnered with Platform Industry 4.0, who many of you may be familiar with in Germany, and produced a world tour covering a number of different cities around the world. And then we decided to expand it beyond just manufacturing and partner with regional associations and groups like RIoT to cover broader beyond manufacturing verticals such as smart cities, intelligent transport systems, mobility, energy. Any industry is being disrupted by this new technology, so we want to put our thought leadership out there to increase the adoption of the industrial internet. So that's kind of the history behind this global event series, and we're really happy to be here. I want to make sure that you know that there's other events. You can go to our website and find them. We will be in Cork in May, if you care to be traveling to Cork. We will be in Anaheim in September and in Sydney in November. So all that information is up on our website.
And if you're interested in participating in future events or hosting, you can talk to either one of us, but really, Kathy.
Yeah, we're always welcoming hosts and people getting more involved with sponsoring. I also did, from a little housekeeping standpoint, want to mention that all these presentations that you see today will be made available on our website. It takes us about a week to turn it around, and we'll notify all of you when they're available so you can download them from our website. And I think that's it.
That's it. Do we introduce the next
Nope,
person?
then we'll turn it back over to Richard. Thank you, everyone.
Thank you. Sure sounds like join the IIC and see the world. Okay, thanks. You got that one. That was pretty good. If you're interested in more detail about how you're going to learn over the day what IIC does and what RIoT does, if you're interested in participating in IIC, there are people floating around with staff ribbons on. They're green. We call them staff infections. I'm sorry, it's early. And if you're interested in participating in RIoT and you don't know much about that, Tom will be here as well as some of his staff, and I think they've got staff infection badges as well. We'd be delighted to help you with that, or you can stop by the desk and we'll make sure you get information. With that, with the boring stuff over, we're going to go straight into the material. Our first speaker today is a keynote from LHP Engineering Solutions. Sorry, I got to check every time. Sven Schrecker is the chair of the security working group at IIC, and he's going to be talking about automotive trustworthiness, a road to a security model, based partially on some of the work that was done actually this week on the security maturity model. Sven.
All right. Thank you, Richard, for the introduction. I appreciate that. As mentioned, my name is Sven Schrecker. I am the Vice President and Chief Architect for Cybersecurity at LHP Engineering Solutions. And you're probably thinking, what in the world is LHP Engineering Solutions? So up until a few months ago, I would have asked the same question. So I just came out of Intel. I was at Intel for 15 years. I was the Chief Architect for IoT Security Solutions. But I wanted to work in automotive. And I wanted to switch out into a company that was very agile and very quick to adopt new technologies and to drive them forward. So I found this little company in Columbus, Indiana, that had headquarters in Columbus, had an office in Detroit, had an office in China, had an office in Europe, and was setting something up in Southern California, which is where I live. So I thought this is the perfect opportunity to jump in and really make a difference. And so today we'll be talking about the infrastructures, specifically on automotive. So we'll be talking transportation, but I'd like to focus on automotive and some of the challenges that we have within automotive. So to give ourselves a frame of reference here, we need to go back to industrial internet and the industrial revolutions. So we're now in our fourth industrial revolution, right? Industry 4.0 and all those. So it all started, though, back in 1784-ish, late 1700s, with steam, with the mechanical production equipment and shifting away from animals and human power into mechanization. And so fossil fuels were coming in, mechanical power. And then our second industrial revolution kicked in about 1870, division of labor, electricity, and we start to see these shifts in society. Things were actually changing. So electricity distribution and such. So as society changes and there becomes more urbanization, we see a shift, which leads to our next innovation there, which was in the late I don't know, 1960s, early 70s or so, which was electronics. And that's when we get into automated production through the early robots, computer systems. And then finally where we are today in the fourth industrial revolution, it's a little bit hard to say because we're in the midst of it, is our IoT. It's the Internet of Things. We have the cloud, we have the edge, we have the fog, we have all of these different components working together. So how did we get here and what's going to happen next? So if we look back, and I dug up an illustration from 1919 in Scientific American. So this is what they thought from 1918, what 2018 would look like. And you can see it's even a bad reproduction because of the print bleeding through and such. But they really thought everyone would be driving in an autonomous car. And you look at this and you say, well, certainly not 1918, but it's not too far off. So even back then, if they could predict and just be in the ballpark of what things look like today and the things that we're wishing for today and the things that we're trying to build, maybe we're on the right track here. Maybe there is a way to sort of project going forward. So in 1940, this is what Tokyo looked like. And Tokyo had also visions for how to expand. And so they published their vision for 2011. And here we have the flying cars coming off all the roofs, and we have the multi-layers. So if you overlook the fashion, and if you overlook the flying cars, the multi-level roads, it's really not too far off. So again, maybe there's something to the prediction process. So in terms of predictions, we did have folks that said, well, this may not work out the way that we thought it would. And so here is a 1831 cartoon of what the road traffic would turn into. So this was in the early days. And it's a little bit difficult to see there, but the vehicles, they're all belching smoke and pollution. There are people yelling at each other from the vehicles. So prediction for pollution. Road rage was predicted, right? So there are certain obvious outcomes here that can be predicted. So looking at ways that we can prepare for the future, if we look at some of the safety issues that have historically happened, comparing different modes of transportation. They always tell you flying is the safest mode of transportation. And everybody says, oh, okay, yeah, that makes sense because we don't fly that often. Well, so here are actually the statistics. So I actually went and dug it up. I could only find the ones from Europe for reasons that I can't explain. And if you look at this, you can actually see there that you are actually you're 40 times more likely to die in a car than in an airplane. Okay, well, those are actually pretty good odds there, right? And airplane and rail are actually very similar. So these seem to be the really safe modes of transportation, and that makes sense. And the bus is also in that ballpark. But between those, let's say the bus and your own private vehicle, you're 10 times more likely. Okay, so what's the difference there? Well, we control the car. The car is something driven by us. The rail is on the rails, right? Which always surprises me when people get hit by a train, right? If you just stand a few feet off the track, it'll go right by, right? So don't walk right on the track, walk next to the track. So the car is steered, controlled by the human. Now, if you look at the motorcycle, you're much more likely, you're 12 times more likely to die in a motorcycle wreck than a car wreck. And that's obvious, right? That's a matter of the lack of protection. So if we extrapolate that out and see how that's changed over the years, the dark blue line, a lot of lines here. The dark blue line from the bottom left to the upper right is our population. And then the light blue line. What we're looking for is, can you see this here? So underneath the orange line, this blue line here. So these are the actual traffic fatalities. And there are a couple of interesting places in here where we had our war. So there was a big drop, mostly because of rationing. We had here a drop due to the energy crisis. And interestingly, here in '85, this is about where the seatbelt laws kicked in. But the traffic fatalities actually went up for a little while before they started to turn around. So maybe that's an adoption issue. But it comes back down since then. It's a nice little slope. But, sorry, wrong one, this one. But we're still at about 35,000 a year, and that's down from 55. So is it better? Yes. Is it as good as we were hoping for? Certainly not. So the challenge here is that we're looking at pieces of a puzzle. So for example, we're looking at the safety issues. And in today's environment where we have autonomous vehicles driving around, one unexplained or one fatality will actually stop the system for a while. And it'll just be a sudden backlash on that. So as a society, that's a good thing. We want to have safe streets, but as a technology, that's a challenge. So we need to look at the safety aspects. We need to look at the security aspects. We'll talk about that today, how the security and the safety are actually tied together. And very quickly now, thank you GDPR, we'll be looking at privacy. So if we're looking at the big picture here, in the beginning, it's our safety and our reliability that's driving our innovation in, say, for example, automotive. So if it's not safe, it's not on the road. If it's not reliable, people won't buy it. So these are the two things that the automakers care very much about. However, as I mentioned, privacy is coming. The resilience of the vehicle is certainly something that needs to be looked at. And it's really the the security that enables all of this, okay? So if you have a secure vehicle, but it can be compromised, you no longer have a secure vehicle. If you have a reliable vehicle, but it can be compromised via cybersecurity, you no longer have a reliable vehicle. Privacy, obviously. So what does that do to our future? So we want to get to the point where we have connected vehicles, where we're always connected, we're streaming data, data will be our new currency. This is where the innovations come from. This is where the enhancements come from. This is our future. But we also want to have the electrification. We want to have it be greener. We want to have more capabilities. This technology is up and coming. How do we assure that it can continue to evolve over time? And finally, the autonomy. This is the ultimate goal. We want to have top-level autonomous driving to get us around. And what we'll be looking at could be something like this. Now this is where we really want to get to. And interesting, if we back up again and we take a look from the 1950s and 1960s, they predicted what the road would look like. This is not too far off from what would be the ideal for us even today. And in fact, if you go look at the advertisement, well, and so the problem is that predictions, and I'm going to heavily paraphrase this to keep it appropriate, but predictions are like dogs, and everybody loves them, but they all stink. Now, it's not quite true. Number one, it's not the correct analogy. Number two, not everybody loves dogs. I do, though, and they don't all stink. But as far as predictions go, they're all terrible, right, to some degree. Picked out a couple here that are real winners and kind of hit it close. But in this case, this is actually an Intel ad that you'll find on the internet that is showing their autonomous vehicle. It doesn't have front seats and back seats. They all face each other, just like the other picture that we saw. So really, if we're looking at predictions and the ability to steer the technology, right? Are we steering the technology through the predictions, or are we predicting something that we expect to happen? Open question. But if we're going to make predictions on technology, why would we not include all of the capabilities for the safety? So if we don't have the safe vehicles, we can't do anything with them, right? They're not going to be on the road. So even today, if you go buy a new car, right, they're very reliable. If you buy a car today that doesn't go 100,000 miles for you, something went wrong. These things should all go 100,000 miles. They're all safe. They get validated and certified. Well, but they don't actually check for cybersecurity. So we need to figure out what's really important, and we need to start there and start rebuilding again. So if we look at what we actually have to use to work with, number one, we need to start looking at the trustworthiness of these vehicles. It's not one problem. It's not the security. It's not the safety. It's not the privacy. It's all of those. Those are one big problem. If you have a non-reliable vehicle, it's not trustworthy. If you have an unsafe vehicle, an unsecure vehicle, something that's not resilient, it's not trustworthy. It's all about the trustworthiness, not just about the safety. So if we start to build up assurance cases to say, this is why this is a trustworthy vehicle, and this is why I know this is going to do what I want it to do, we can start putting into place some standards And once we have standards for automotive, and we'll talk about those in a moment, we can actually start validating against them. And if we can validate against them, we'll have some level of assurance and something to measure them by, because today there is nothing. So if you look at a vehicle and you break it down, or really any IoT system, and you break it down into its constituent components, what you start with is the things. These are the actual things that do something. And they need some kind of security capabilities. So they need to have an identity so that you know what it is. And they need to be able to have some kind of cybersecurity defense mechanisms. They need to have physical security defense mechanisms. And if we could do that across the board, just snap our fingers and magically have this happen, we would be much better off. But that doesn't actually solve our problem, because these things all talk to each other. So we need to look at the communications as well. And if you look at the communications, and like we said, we have an identity on each of the things, we can leverage that identity to authenticate between them. Now you authoritatively know what is on the other end of the wire, what are you actually talking to? And once you have that, then you can build on top of that. You can do authorization. Am I allowed to talk to this? What kind of information can I give it? And then it becomes arbitrary what your rules are. You know, who is it on the other side? What time? What location? What, you know, whatever the different parameters are, these can all be defined. But even that's not enough, because that will work on day one. If you deploy it out in the field and hope that your security works going forward, how do you know? You need to be able to monitor it and see what's actually happening out in the field. And then you need to be able to manage it. What do I do when something goes wrong? So we have new crypto algorithms that have been broken by quantum computing. I need to swap all this stuff out. Well, if I didn't think about that in advance, I've got a real problem. Luckily, the update scenario is very prevalent nowadays, so we do have solutions in place for that. For new equipment, some new equipment. For legacy stuff, that becomes very challenging. So we don't look at just the security of the things or just of the communications. It really has to be the big picture. And I think that's a common theme here. So in order to figure out whether we're doing the big picture right, we actually need to take a look at the pieces. So how do you evaluate something? So there are all kinds of tests that you need to run on the thing to really get a good idea. So there's the threat analysis, the risk analysis, the vulnerability analysis, the concepts, the specifications, the reports, et cetera. There's a lot that needs to go into this. And if we don't find a way to formalize this, how will we ever get there? Everybody will do it different, and you'll never have a quantifiable value that you can base any decisions on. So what do we actually have to work with today? Not a lot in automotive. So to start with, the ISO 16845 CAN, that's the control area network. That's what all the messages are sent on. When we did the GPAC, that was actually used. So the radio system was hacked because the password was there, but it was guessable. And you can guess it based on the VIN and the time of day that the VIN was assigned, and then you add 20 seconds past midnight, and you can deduce the password. Okay, so good try, wasn't quite good enough. They could get in. From there, they were able to hack one of the gateways by replacing the firmware. And the firmware, it had a checksum. You knew that it had changed, but nobody was checking. And so it didn't matter. And you just replace the firmware and make it do whatever you want. And they just start sending messages on our friend here, the CAN bus. So we can certify this CAN bus, but we can't certify the security of it. And it turns out that it's not a great design. It was built without security in mind, and so that makes it challenging. UDS is our diagnostic system. That was actually what was compromised. And ideally, that only runs at up to 5 miles an hour. But once you're on the CAN, you spoof the messages from the tire pressure system, and that's what's telling you how fast you're going. So you say, I'm only going 5 miles an hour when you're really going 25 miles an hour. And then when you send a command to turn left, well, it'll go ahead and turn left because you're in diagnostics mode and it'll do whatever you want. So that was the GPAC. Following all the standards, everything was correct, but still we were able to compromise it. So here comes ISO 26262. This is a functional safety specification. 12 volumes, covers everything about failing safely, et cetera. 2 volumes talk about security. Well, they all mention the word security in the foreword, saying this was updated in 2018 to include security, but they never mention security, except in 2 volumes. One is motorcycles. I don't recall what the other one was. One of them had a nice appendix that had a lot of security information. One had a little short paragraph about over-the-air updates. But at least it's in there. And what it does is it sends a warning. It says, you're on the hook for security if you follow 26262, which you should. It's functional safety. Okay, but it doesn't tell you what to do. So this year, ISO and SAE are producing the 21434 specification, Road Vehicle Cybersecurity Engineering. Unfortunately, it's a process document. And what it says is you need to do a threat analysis, you need to have a plan, you need to track the plan, and we'll audit it. So OK, now we can audit it, but it still doesn't tell us what to do. So we have a couple here, SAE, and so J3101 and 3061, that give you some kind of guidance, but not really. It's not really a lot of actionable content. So what do we do? Well, it's actually quite a complicated problem. There are multiple layers, there are multiple components. So you pick an ECU someplace, and you start diving in and picking it apart, right? There could be flaws in the hardware. Coming from Intel, you know, we ran into Spectre and company, and you know, it happens, right? So there are those flaws. There are flaws in the boot process. The boot process is maintaining the integrity for the whole system. There are flaws in the applications. It could be hypervisor, it could be a container, it could be a native firmware application. These all need to be checked, right? But then there's the data, there's the monitoring, there's the configuration management, there's the policies, there's the development environment, right? So even if you go through and you do everything correctly and you sign your software when you push it out over the over-the-air update, well, can it still go wrong? When did you actually sign it? Was it the last minute before you pushed it out, so it's been sitting around on a drive unprotected? You know, there's all sorts of flaws in the process. So we know we'll never be secure, but there's a lot that we can do better. And even if we lock those down, there are all these different interfaces and ways to get into the vehicle. So the challenges are always there on how do we protect these things, and how do we learn about them, and how do we advance the technology? Well, we're from the IIC. And what we do is we build out test beds. So we publish a whole lot of papers, and we do a whole lot of thinking, a whole lot of talking, but then we actually prove it, right? So one of the differences between the IIC and other organizations is we put our money where our mouth is. So we will build test beds and challenges and special interest groups, and we'll take some of the things that we're advocating and we'll prove them. So we have a go-kart here, which we are participating in the Purdue Autonomous EV Vehicle Challenge. So this is held at the Indianapolis 500 during the time trials. Let me go this way. On the infield, and they have a track where the kart drivers drive all day. But then at one point, Purdue comes in, and we put autonomous karts on the track. So last year, they could be human-assisted. This year, they can't. This year, they have to be totally autonomous, 5 laps. And in either the 4th or 5th lap, they're going to put a barrier in between. So you need to be able to sense it, avoid it, and keep going. Fastest kart wins. Next year, all karts on the track at the same time. So this is where we get into artificial intelligence. This is where we get into the real driving scenarios. So it advances a little bit each year. And these are the kind of tasks that we get into in the IIC to really demonstrate that we are making progress and to show what could be done, to push the envelope, to make our mistakes on a little track on the infield of the Indianapolis 500 rather than on the road. So there's always unintended consequences. We don't want to be in a situation where we'll find that we have accidents, we have failures, we have things that happen over and over again, and we just can't get this quite right. When we get into the machine learning and the artificial intelligence, things get better, but it's really hard to tell why. What is it learning? What is it doing? It's not so easy to debug anymore. So how do all of these unintended side effects get handled? Well, one side effect was that my son, who's 15 now, I went up to him and I said, all right, time to start thinking about the driver's license. You know, how are we going to do this? And he said, why would I get a driver's license? I said, well, how are you going to get a car? He said, why would I get a car? I don't need a car. If I need a ride, I have 2 friends that have cars, and I can just call Uber. And I thought, oh, you know, he's just being difficult. But I've been hearing from other folks, they have a 17-year-old, also doesn't have a license, has no intention of getting a license. It's actually a thing. These are unintended consequences of the technology. We're not even talking autonomous driving. We're talking Uber and ride sharing, right? These are very minor shifts. So imagine what happens when autonomy kicks in. Well, if it does kick in, and we have accidents, now what? So imagine you're in the the insurance industry. All right, this person got in an accident, but it wasn't the person. He wasn't even touching the wheel. Right? He was not in control. It's not the person's fault. What do you do with that policy? How do you ensure something like that? Do you need to go to applications? Is it the car dealers or the manufacturers? Are they responsible? Are there fleet owners? Do people not even own vehicles anymore? Right? This starts to get complicated pretty quickly, and all we've really done is project it out into, the simple autonomous use cases. So there's a whole lot more going on. It's a big ecosystem, and we have a lot of surprises coming at us. So as an industry, we need to evolve. Pieces do not evolve in isolation. We have to keep them all together. We have to look at the big picture at all times. So if we all work together, we can put something together. Now, it might be ugly, and it will be ugly, and it is ugly, to be honest. But we're making progress, and we add the pieces together, and it gets better and better over time. But there's still one more challenge. So bringing us all the way full circle. At the beginning, we were talking about our industrial revolutions. Every time there's an industrial revolution, there's a major shift in society. So what are one of the shifts that we have to look forward to? If we map the industrial revolutions on a time scale, it took an infinite amount of time to get to the first industrial revolution, from the dawn of man, whenever that was, to 1784, right? That was our first industrial revolution, mechanization. It took about 100 years or so to get to the second industrial revolution. Then on the order of about 50 to get to the third, about 25 to get to the fourth. So this one should last 6? How long are we into it? Are we about halfway there? Should be looking ahead to the next one, because that one's only going to last 3. The one after that's only going to last 18 months. The one after that starts to get to 9 months, sub-year. How can you sustain this level of evolution with the rise in complexity? And that's a exponential rise in complexity each time. What kind of constraints do we have in place for that? Okay, so even if we get our technology to work, even if we start advancing pieces, if we don't have the whole ecosystem in lockstep, we're not going to be able to manage the complexity over time. So I leave you with the thought that even if it appears we're making progress, even if we have definitive proof that some of these technologies are coming together, it's not enough. We have to evolve as an ecosystem and as a society and put the proper constraints and controls in place. The fact that we have no standards for automotive that deal with security and the ones that are coming are insufficient, that's not a good thing. The fact that we can't validate the safety of a vehicle because we don't even look at cybersecurity, that's not a good thing. The fact that we don't actually have the processes in place to deal with the upcoming complexity and the speed of evolution, that's not a good thing. And then all the unintended consequences, all the societal impact, what happens to jobs, what happens to people, we were talking about the geographic dislocation, right? If things like the Hyperloop come in and you have communities springing up in the middle of nowhere because there's a wormhole from one spot to another, a big high-speed train. How does that affect things? I mean, there will be a lot of changes. So my guidance here is that we look at the big picture, always take a step back, see what's really going on, and realize that things are changing and we need to adapt quickly. Thank you very much.
About 5 minutes for questions, if you want to take a couple questions.
Do we have any questions?
Or is it all obvious? Are you all depressed? Yes, sir.
Question here.
Yeah, so the big question as I see it, when I think about security, the world economic system full of money around the world arguably is the most safe and secure environment that we've got. I couldn't think of one more secure. I don't quite understand, and I've been a big proponent of thinking autonomous was coming. I don't quite know how you do that because everyone in that system is well conscious of security. When you put this vehicle in the hands of the average consumer, the sort of things that they can do, and then when they go to get it repaired and fixed, there's always going to be somebody touching that vehicle that you don't know the level of their security or what their incentives are. And that's what I'm really trying to wrap my arms around in terms of getting to where you want to be.
Okay, so how do you, and it's sort of an ecosystem question. How do all these things come together with all the different people touching it, and how does the consumer actually, is the consumer the right person to handle that? So if we were to snap our fingers and make these vehicles secure today, some of the unintended consequences would be that the dealerships would have very limited ability to modify things. The repair shops would really not be able to replace anything, right? It would just be just rip and replace, which is not all that different from today. They're all Legos anyway, but they really wouldn't be able to do anything. And so the aftermarket, for example, would be completely decimated. So there are a lot of changes that have to happen there. So maybe consumer vehicle is not quite ready for the full security solution. So I'm not talking autonomous, I'm talking about the security aspects to it. So let's think about tractors, heavy equipment. Let's think about trucks, right? The big 18-wheelers. What about other vehicles that are much smaller, forklifts, for example. They're indoor and they're constrained places. So forklifts is a great example of a very autonomous, friendly environment where you have a lot of control and you can have very tight security constraints, right? Tractors, although they're distributed and they're out in the field, there are already autonomous trailers that'll pull up next to the tractors that's going. You dump your load into them and off it goes. The tractor never stops, it just keeps going. So these are examples of ways that we can test out the technology and get familiar with it and solve some of these problems. Jumping right into it, there are not enough pieces to support the entire ecosystem. Now, if you talk about the economics of it, vehicles are very price-friendly today. And I believe that compared to the inflation, they haven't really gone up as much as they should have. So comparatively, vehicles are very cheap today. But if you actually go in and add autonomy to it, those are all expensive parts. So even if you want to go in and out of the 140 or so processors on a vehicle, you want to start adding security, the price is almost cost prohibitive. So how do we get there, right? At some point, something has to give, right? Does the price go up to the point where consumers can't afford to buy a vehicle and they're all fleet owned? Maybe, like my son, they don't want a vehicle, right? And so there are companies, so Uber and Lyft own the vehicles, and they come by and they pick you up. Flying cars, jetpacks, hyperloops, right? We don't know where this is going to go yet, but it certainly won't look like it does today because the model is just very difficult to sustain from an economic point of view, from a security point of view, and just, if there's that many autonomous cars moving around all the time, what do you do with your autonomous car? You don't have to park it when you get out, just have it circle the block. But if everybody does that, now right? So there's all kinds of problems there. So again, my guidance is we need to look at the big picture, and these technologies are great, but let's understand what it is that we're getting ourselves into.
I'm sorry we've run out of time for this session, but you're going to be here the rest of the day, Sven?
I'll be here up until noon.
I'm sure that conversation is going to continue offline when we take our break. But
all right.
Thank you very much. I have to tell you, you have 15 years to look forward to. I have a 30-year-old and a nearly 28-year-old. Neither one has a car or a driver's license, and no interest whatsoever. The millennial generation has a 23% rate of kids that just don't want to have driver's licenses, have no interest in driving.
Caught me off guard, so that's my bad. I got to look at the big picture
too, but that was 20 years ago.
Thank you.
When I was 3 years old. Changing gears a little bit, we're going to be talking about smart cities and smart power. Stan Schneider from Real-Time Innovations is here representing both the IIC and RIoT, so perfect person to give our next keynote. Stan. Thank you.
Thanks. Hey, everybody. So first of all, raise your hand if you don't know me and you do know what RTI stands for. You just told them. But most people around here think RTI stands for, what is it, Ruby Tuesday Incorporated? No. Restaurant Technology Incorporated? No. It's Research Triangle Institute? Yeah, that's somewhere around here. Anyhow, RTI, Real-Time Innovations, we do connectivity frameworks, and I'll talk about that a little bit. I'm going to try and take a step away from the autonomous vehicles, although we're very active in that world too, and talk about the power world. So first of all, a little bit this is my whole slide on RTI. We are an AI enablement company is the best way to look at it. Enablement technology, we take intelligence, and I call it functional artificial intelligence. It does not necessarily deep learning and backpropagation, all that, but very intelligent things, and connect it to large distributed systems and very intelligent systems. My humble opinion of the IoT, it's not one thing. Everybody knows that. In fact, I think the IoT is a $10 trillion market that consists of $1 million, $10 million opportunities. If you think about it for a while, it's not that far off. But they sort of all fit into three big, I call them spheres, of applications. The first one, device monitoring, huge market. The entire consumer IoT fits into that. So your Fitbits and your Nest thermostats and your everything that you think of as device for consumers. In the industrial space, it's things like device monitoring and health checking, things like that. Where you got a single device talking to a cloud service. Our point of view, not real interesting. Connectivity's too easy. Next class is you put lots of sensors on a plant, you get it off to the cloud and think about it to optimize things. This is the Predix of the world, MindSpheres of the world, where you're trying to do some level of AI optimization, things like that for the plant. We work only on edge autonomy. Edge autonomy is where the action is between devices and things outside of a data center. Data center might be involved, but it's not the main player. The main player is connecting things together. And I'd like to start with sort of a case study here. Anybody in the power industry in the room? I'm sorry, you're going to have to leave for a second. No. This is actually a brand new released product, so I finally get to talk about it. It's sort of cool. This is a technology for building large distributed power systems. So one of the things I'm going to talk about a little later, Indra is the customer here. We actually started out with them a while ago. It's got to span industries. Something that is really important to do that. We started out with security and defense, and then air traffic control. They do a whole bunch of air traffic control around the world. And now they're taking that same technology, the same architecture, and putting it into energy and industry space, which is really the power of the IoT. I'll talk about that in a second. But I thought I'd start with a little video. Maybe I'll turn it down just a little bit so I can talk over the music. No, they did it for me. It's a little too much. So I wanted to give you a feel for the magnitude of the challenge. So this is a power system here, and it has to be high quality. It has to have optimized performance. It's actually a pretty big system. There's people involved watching what's going on. You got to have field service that can take and interface with the system out there. But now you look at what's going on with distributed energy resources, with solar and wind power and batteries and things in the field. You need to integrate those together. They have to have low-cost devices that are involved that actually are reliable for switching all the power and stuff like that. This is their solution. Notice it has geographic challenges. Some of these systems are very geographically spread out. And now you've got a lot of expensive things in the field. They call them assets, where you have to manage those kind of things. You have to have planning tools to figure out how you're going to install these systems out there in the world, which actually isn't at all a trivial thing to do. There's sort of a don't underestimate maintenance. Just because the system's installed out there doesn't mean you have to maintain it. You need to talk to your services people, find out when things are going on. And then for a grid, one of the biggest problems is called distribution management, where you're trying to figure out where to put which power where, and maybe do some smart distribution management when you got expensive power systems. Ask people to turn down their use. It's got to connect with field service. I mean, this is a typical challenge, unfortunately, in the smart city world. Is it's not just one little thing. It's many, many, many things that really have a far-reaching area in a lot of different kinds of parts of the system. And then you got to look at the technologies. So you need to have some way to, by the way, anybody know Duke Energy, they started this open field message bus called OpenFMB. Anybody heard of that in the room? A few people. So this is a sort of earlier version of that they did this, but this allows you to do what's called islanding and have sections of the grid that might be disconnected from the rest of the grid for a while for various reasons, so you can pick up local power generation. And then there's a lot of issues with power flow analytics. And then it really gets more real. You have to have operators out there, and they have to know how to operate all this stuff and make it work. So that's just the technology that sort of puts the stuff together. It gets, it's also got to run on everything, so on iPads and phones, and so the people can use it. These systems can get large. It can be very large. It also has to deal with the business side of it, how you're going to buy and sell power. The grid is, in reality, not just a power delivery system. It's also a business that has to trade things. And the challenge of all of this, to actually build an architecture like this, you've got to have some way to make it work, and then it has to always work. I mean, if your power goes out, it's something you notice pretty quickly. So I don't want to do too much more of this. I just want to give you an idea of what they are. I'm going to go through a quick little example here of a smart city being built in Australia. The smart city has a huge advantage. It's all owned by one owner, in this case a university called Monash University. It's a reasonably big university, it's like 70,000 students, so it's not a small thing. I think this campus is only half of that or something like that. But their goal is, they got some money, they got a lot of excitement from the government to go and do this, and from the university. But if you actually look at the challenge here, you're starting here from zero down there, and you've got to, the first thing everybody thinks about with distributed energy resources, I got to do edge computing. I have to have a smart wind turbine or a smart solar system. Actually look at this thing. You got to forecast the solar. You got to integrate with the rest of the grid. You've got to connect it with the architecture, and this has to evolve over many years and many iterations. But the fundamental change is going from what was a centralized control. The grid today is almost all centralized control. They have these central stations, and all of the analytics, not that much of it, all the data from the system comes into that central station. They run what's called a state estimator to guess how much power you're going to need, and they change how much power they're going to generate, typically on about a 15-minute cycle. If you've got solar and wind and the sun goes under clouds and things like that, you need second cycles or even less cycles. It's got to be much faster. So the challenge is huge. So how you do that, it really, if you actually take a look at the system, the fundamental problem is a data problem. For decades, really, the world has looked at computing systems as boxes and connecting things together, sending messages around, that kind of stuff. But to really make something like this work, you sort of have to realize that the system science, the best definition of a system I've ever heard is a bunch of things that share information. If you share information, you're a system. And the trick here is sort of put it in the middle. So this is sort of the design here. It's based on a standard called DDS, which is interesting, publish, subscribe, but they've sort of replaced the entire architecture so that there's not some special standard called 61850 Goose that runs just the substation, and then another thing at the next level up, and another thing at the next level up, and an enterprise thing. This allows you to have a consistent data infrastructure across the entire system. So even though the volume's changing, the processor capability is changing across the system, it can work across the thing. The ISC's been working on this for a while. We actually call this the layered data bus architecture pattern. I'll get into a little bit of the technology later. I just wanted to point that out. The real trend here is to go from the centralized model to the distributed model. It's not an instantaneous change. You have to sort of build that over time. But it really is at the very beginning in the utility industry. There's very few of these kinds of systems out there. There's lots of designs and talks about it, but it's still pretty new. Their implementation, I put this up here for the IIC people in the room. This looks like a 3-tier architecture, except they've got a 4th tier in there. So the 3-tier architecture is sort of the edge devices and things on the left there, and then the 2nd tier is the first thing you connect to and collects data in the cloud, and the 3rd tier is really doing analytics and back-end integration. But this isn't really fair because that's not really a tier. It's really just an indicator of the data that is available to everybody else in the system. So it's actually implementing 3-tier with a layered data bus for those of you. It's not like this is a new architecture, by the way. It's been well done, mostly in the renewable energy space. The same architecture is now controlling the western grid at Grand Coulee. Grand Coulee is the largest power plant in North America. They used to control the grid and all the high level, the gross level power changes with a network of 14 plants with operators on the phone 24/7, calling each other and asking them to change their operating parameters a little bit all the time. Grand Coulee is nearly 7 gigawatts, and all by itself it could balance the grid. They had to rip out all the electronics and put in an autonomous intelligent system that analyzes the grid and makes that all work. So that's been running now for about 5 years, and pretty much the rest of the hydro portfolio as well. Also a lot of wind turbines. Duke Energy's driven OpenFMB as well. I suppose that's a couple of years old now, but the renewable power industry is really transitioning this. I don't want to give you the idea that it's just power industries that can use this. The real power out there is having the same architecture across many things. So the same design I'm going to talk about here for a second runs air traffic control and autonomous vehicles and underwater vehicles. And we actually have a fish farming thing that can shoot lice off of swimming fish with a laser. It makes it much more sustainable. It's a long story. Some of you in RIoT may have seen that video. Anybody see that video in the room? Because we showed it at a RIoT event a while back. It's pretty interesting stuff. We have flying cars and intelligent medical systems and trains. All of these things have something in common. They're all systems and they all need to share data. And if you ask me what the industrial IoT is really, I mean, what's going on out here? Yes, it's a fourth industrial revolution or whatever. But what's really happening is disrupting all the industries. Is all these industries are facing the same kinds of problems. A Stanford Business School definition of a market is a group of consumers with similar needs who communicate. 10 years ago, 5 years ago, they never communicated. I actually give the ISC credit for creating a venue where these different industries can communicate, and it's the first time there's actually been a market for this sort of general purpose architectures, and certainly not just in connectivity. So in my humble opinion, what it's really all about is combining technologies and lessons learned from all industries so that you make every industry better. It's really an interesting thing. But you have to have an architecture. Anybody software in the room? Software people in the room? So what's the worst description of software you hear? Hint. Hint right there. Spaghetti code. Spaghetti code is just impossible to deal with. And the biggest cause of spaghetti code usually is actually data flow issues and coupling between things that you don't really want. So I'm going to try to introduce how the DDS standard works and the layered data bus pattern works. And I will warn you, you're probably not going to understand it here. This is actually a picture from my favorite ski area, Squaw Valley, KT22, which is sort of a famous mountain. I'll tell you, if you're not a great skier and you get on the KT22 lift, you have made a mistake. It actually says, expert only, no easy way down. I changed it to the mind change here, the mindset change. It really is a different way to think of the world. And until you realize that, and it'll take a while to do that, it's sort of hard to get there from here. And the fundamental thing is to put data in the center of the architecture. And it seems like it's very, very different. It's actually not that different. If you know what a database is, you already know how to think data-centric. If you are writing code for a database, you have a database and your application interacts with the database. There may be 5,000 other applications also interacting with that database, but you don't know that. You have a sufficiently rich interface that you can work with a database. So the only way how the data bus works, which is slightly different, is actually a future database. Database is stored information you can search. A data bus says, oh, get me something in the future. Get me phase variance of wind turbines. Get me feedback signals at 3 kilohertz from my control systems, and it'll actually go send that specification out and deliver it to you. But all your interface is just like it's shared memory. So I told you it's a mindset change. But the big difference is no more, no messages, no clients, no servers, nothing like that. Everything you've known about distributed systems is sort of thrown out the window because it's handled by the infrastructure underneath. So a way to think of it as a data everywhere abstraction. All data is available everywhere, as if you had everything magically there. It's sort of magic. It doesn't really do that. The trick is it doesn't, instead of sending all the data everywhere, it asks everybody exactly what data are you going to need when. And that is well specified in the standard. There's 22 quality of services in the standard, depending how you count them all, 24. But you specify, I need this data, here's how big it is, I need it at 500 times a second, I need it with this reliability, I need to know that the sensors are live, so if you have 380 wind turbines out there and you're trying to do phase control, you need to know that you actually have connectivity to all of them. You can actually ask the data, make sure you're being updated every 100th of a second or something like that. You don't have to find that out, just ask. It's a quality of service specification. And then it can all, since it looks like your own shared memory, it looks there. It looks like it's your own language, your own operating system. It doesn't matter what the transport is. It comes over wireless or wired or fiber. It doesn't make any difference at all. So really think of it as a distributed shared memory is another way to look at it. The fundamental thing it does differently is because you're just looking at shared memory and that's sort of your own little world. If somebody else comes along and wants data, it's not going to change. So the flow is not coupled. And flow rates and discovery things, you Things can come and go. They can live anywhere. It can live in the cloud. It can live in the fog. It can live on the edge. It can live in a device. It really doesn't matter. You don't have any idea because you're just talking to it locally. And then importantly, timing, things, there's no startup sequence issues. A longer term timing thing is really interesting. The large distributed system, it's impossible to update, especially with many different kinds of devices, impossible to update all the devices at once. You can't just say, okay, everybody in the room, right now, update your app on your phones to be the next version. The app on a phone is actually you could do that because you could push it all out at the same time. But if you're trying to do this, something in time scales measured in milliseconds or even years, it doesn't work that way. So you have to be able to evolve the system as the system evolves and interoperate with old devices, with old versions of software and things like that. It's a more subtle time coupling out there. Anyway, data centricity gets rid of all of those things because you're just talking to your own memory. It's really an interesting way to look at it. So RTI, I was told I could talk about RTI here a little bit. Data-centric sharing lets systems cooperate. Decoupling lets them work independently. And that's our tagline, is your systems working as one so they can talk to each other. But I try to give you a little more intuitive thing. What's data centricity really all about? If you go look at the standard, you'll see all sorts of big fancy terms like a shared global data space and quality of service parameters and things like that. The way to really think of it is not like this is hard, but think of it as you're writing a bunch of applications, they all have to interoperate, they all have to be able to work, and that entire system data, everything from the top to the bottom, is all inside every device. So you really have everything you could ever want because it's going to go and get it for you. Another way to think of this is if I told you I could ship you every newspaper on the planet every morning, physical newspaper, do you believe I could do that? Everybody in the room. Every newspaper on the planet tomorrow morning. Can't do that. It's way too many of them. And magazines while I'm at it. But if I said, okay, I can get specifications, you want Sports Illustrated, you want the New York Times at 6 o'clock in the morning on your doorstep, you want the London Chronicle or whatever just on weekends, and I take all those specifications, I look at the capability of my system, do you believe I could provide exactly what you want, not necessarily everything? Anything, but not everything. That's essentially how this works. It makes it look like everything you could ever want is available. You have to, the trick, the catch is you have to say ahead of time what you want. And at the same time, you have to say ahead of time what you're gonna provide. So that's really the thing. The essence of data centricity is really instant, which is actually well defined, but measured in milliseconds or microseconds, access to whatever you might want in the system at any time. And it actually also works over, since it's just your shared memory, it doesn't matter how it got there over networks or shared memory or whatever. It doesn't matter what your processor or language and things like that are. So, and the fundamental thing it's used for, this is the autonomous car world. So we're very active in the autonomous vehicle world. We have about 40 commercial programs going on. So Sven's stuff is closer to reality than you might think. Most of them are what's called level 3. Most level 3 systems are like what Tesla sort of has. If you're on the freeway and it's a very constrained, controlled environment and you're not going to get off and try and go through city streets or something like that, you can run, that's level 3. Level 3, it's called hands off, eyes off, but only in very controlled environments. The way most of those systems work, they have a very high-powered processor. They put it in the center of the car. It's usually a big NVIDIA box with lots of CPU and lots of memory, and they run all the signals to that. And everything runs in that one shared memory environment. And the reason for that is AIs need data differently than most other things need data. One of the first things you learn in the AI world, controllers and all those things have a very well-defined data flow needs, and AI is very hard to predict. It needs lots of data sometimes, and the easiest way to provide that in a big system is put it all in one big shared memory. So what DDS really does is takes that and distributes it. Because it looks like a big distributed shared memory, and data centricity lets you have a new distributed architecture that sort of does the same kind of thing. Another problem is autonomy needs substance. This is a sort of a standard, very simplified diagram of how an autonomous car works. So there's sensor fusion and sensor issues over there, cameras and LiDARs and things like that you have to figure out what the world looks like. Situational awareness is sort of one of the biggest AI problems. Where am I? What's going on? What's going to happen at the next intersection? Am I in the right place here, planning. I've decided I'm going to turn left. I'm going to wait for the pedestrian to cross. So there's a cat there. I'll try and miss the cat. There's a pothole. I can run over the pothole. All these kind of things. But they also have to connect to the real feedback, real-time control systems in the car, and often to the cloud to get mapping and navigation, but also to do maintenance information and things like this. This looks complicated enough. This is just one car, right? There's hundreds of thousands of cars out there. It also has to scale. It's a hard problem. So the layered data bus design architecture pattern I talked about before, this is for the car. I showed you the video, is exactly the same thing for the power world. The real trick is what's called this unified data model. The data model across the whole system is consistent. So it's different shared data at any level. Inside the car, you're sharing like I had on the previous slide with LiDARs and radars and feedback control. You don't really need that next level up for the intersection control or whatever. They just need to know where the cars are, where the cars around you are, things like that. And all the way up at the top, at the high end, maybe the manufacturer just wants to know what the maintenance status of the cars are. So they need doing different information, but there are times it's very difficult to predict when you're going to need something deep down inside the car. So one of the problems with AI is they also want to have training sets. So, training set is, for instance, if you're, driving down the road and you get in a collision or a near collision, they want to take that information and try and figure out what happened to it and what the right thing to do is, and then they run it through their back propagation algorithms to learn what that is so the next time the car doesn't do that. By the way, single cars don't learn anything. They take that training set out of the car and they put it up in the cloud and they run it over and over again, and they take the new sort of smarts, think of taking the brain and downloading it to all the cars. So if your car gets in a near collision and they figure out how to prevent that, they can send it out to the all 100,000 cars. So one of the big differences, the entire system is learning from events that happen to only one of them. But that means that the cloud up there needs data right out of the deep data out of the car, right? It needs LiDAR and radar, or whatever the sensor data is. And that's a difficult thing to do if you have a data architecture that's based on lots of different kinds of abstractions at every level. The layered data bus makes that actually pretty simple to do, or it's designed to do that. Obviously, you can't do it all at the same flow rate, but you can get the data that you might need to do that. I know I saw after Sven, who loves talking about security, I thought I'd talk about security. Systems need integrated data defense. You guys know all these terms. By system edge, I'm talking about things like firewalls, and the machine is locking down your machine and whitelisting, all that kind of stuff. And then network transport security is all the protocols and things that sort of protect the network itself. The problem with all of those, they're sort of all bolted onto the architecture, right? If you're protecting the network transport, for instance, if you get into that somehow, you can send any information you want over it. It's very difficult to lock, a VPN, for instance, is really a form of, I'm going to not let you into my VPN, so it is secure. But if you do get in somehow, you can do anything you want. It's very sort of I like to call it egg cell security. DDS, because it's data flow and it knows all the data flow. I know who's getting every newspaper. I don't have to send you that newspaper. You asked me for the New York Times, you didn't pay for it, or for some reason I don't want to send it to you. I can actually keep track of who's allowed to get this information on a per data flow basis. It actually fits right with the architecture. So security that matches the architecture is really easy to implement by the end user because the architecture itself, the infrastructure is providing that security. So we can actually, have a data flow security problem, data flow security protection, it's called a permission certificate, that allows each application to be controlled what it can and can't put on the bus. And because of that, it's much more fine-grained and much difficult, more hard to hack. Also because it fits the architecture, you don't have to write any code to get it. You have to get the certificate, but once you've got the certificate, the architecture can enforce it. It's actually a lot like the way database security works. If you have a database, you can have users that have different permissions in that database, and there's no problem with other users having to understand all of those things. So. I thought I'd throw together a quick diagram. So this is a classic security thing, and the root of trust, you have to put it in the ground. The edge defense is really the first thing. You got to have some kind of way to stop people from getting there. Host defense, make sure your hosts are locked down. The network defense, this is the kind of security architectures you see all the time. The problem with this is there's no indication at all of what the application is you're securing, right? So these kinds of things, technologies, work for any application, and it's difficult to do that because the real problem might be you're just putting all this defense around a fence that doesn't do anything. And securing the system without considering what the application is not a good defense. It's supposed to be a bad joke. Shouldn't have done that. So another thing the IIC put together is this thing called the connectivity framework. It has this I'm certainly not claiming that DDS, for instance, a standard can do everything. It has its range of things. But we've done a very good job, I think, of understanding all the other standards and having some kind of a selection capability so you can figure out how that works. And another way to put it together, if you're thinking you need this, I will ask you these questions. If these questions you answer 3 of them yes, you probably do need to look at a data bus architecture. Is it really bad if it stops working for 1 minute? So the power grid can't go down, healthcare systems can't stop, autonomous cars can't stop. If you talk about milliseconds ever, if you're a software organization, have a lot of software organization, and you're not just sending data to the cloud, and you're doing something new, you should take a look at that. So I'll skip that stuff. RTI, real-time innovations. We're the largest connectivity vendors in the market. We have over 1,300 applications out there in some form. Come and talk to me. It'd be great to get to know you better. I do think that the real disruption out here is putting together architectures that can work across applications, across industries. The fundamental value is a common architecture that can span industries and sensor to cloud and interoperate between vendors. John Chambers is sort of the CEO of Cisco during their big run-up. Well, I love this quote, you don't compete against competitors, you compete against market transitions. The Internet of Things is the biggest market transition that any of us will see in our lifetimes. It's changing everything. The smart machine era is the most disruptive out there. It's really a good time to understand what's going on. Don't worry about your competitors, worry about what you're going to do with all this new technology. So anyhow, that's what I have. I have lots more stuff if you want it. If you want lots of use cases, I love use cases. We actually run a users group kind of thing for DDS. And there are use cases from hundreds of different places out there. You can go to, we actually host these on our website. You can go look at how everything else works out there. And it's on community.rti.com. Free for everybody. We also have product out there. And I wanted to do a quick thank you for SAS and RIoT and IIC, now with OpenFog, for hosting the event. So, thanks.
All right. Thank you, Stan. Good job. All right. Thank you much. So next I'd like to invite my panelists to come up to the front. We're going to move from talking a little bit about architecture to talking about infrastructure, which is really the architecture of smart cities. So come on up. I'll name them briefly. Here we are. Come on up. I think we'll make this informal. All right. And are we missing?
We got one, yeah, one more coming in.
He's coming. All right. Here we are.
Mic change.
No problem, no problem. All right. Thank you all for being here. I really enjoyed those first 2 conversations, and we're going to continue that now in a group format. Again, I'm Tom Schneider. You saw me just a little while ago, so I don't have to reintroduce myself. But real excited to have a panel of experts to talk about smart city infrastructure and what are some of the infrastructure channels and challenges. And what I'd like to do is let you each introduce yourselves. Jim, I'll let you start and we'll work our way down to Jennifer.
Okay. Well, good morning. My name is Jim Haskins. I'm part of Cisco's Smart Connected Communities team.
Cool.
And I'm Ty Roberts with Itron. We are traditionally more active and focused on utility space, but in the last, I'd say 5 or 6 years, our fastest growing line of business has been smart cities. So what we bring to market as Itron is a communications network for industrial IoT in the city, a streetlight control management platform, and an ecosystem of providers that we've integrated into our network to offer various services to the utility.
Yeah, Chris Bell, account executive, part of the business development team within Building Clarity. Building Clarity is a part of the Brady Train Service, Inc. Enterprise, focused really on the built environment. We've partnered with SAS to take some of their technology into the building space.
Hi everyone, I'm Jennifer Robinson. I work here at SAS on our U.S. government and education practice. And my role is to help local governments use analytics to become more effective and efficient.
Fantastic. So we got a great variety of different voices for this important topic this morning. Let's start, Jim, I'll start with you since you're here beside me. Smart cities, I think everyone in this room would agree that's not something that's coming, that's something that's here. It's something that every community has deployed to some level or another, but perhaps hasn't quite scaled in the way that we know that this will scale. What are some of the biggest challenges right now towards really scaling some of these solutions?
Yeah, so smart cities has been around for a long time. We might not have used that term, right? Mm-hmm. And we actually now refer to it as smarter communities because nobody wants to be the opposite of smart. I think if we look at that globally, we've seen more deployments in India, in Europe, and LATAM. Here in the U.S., I joke in a tongue-in-cheek that democracy gets in the way because we've deployed technology historically in these silos without much regard to how we share the asset or the data from them. Mm-hmm. So now that's problem number one, is that we've got deployed these departmental silos and we may even not know where all our sources of data are or our systems of record. And I'd say the second issue is that in the IT world, we're struggling to maintain the already existing assets, and some smart city sales guy comes in and says, let's deploy 10,000 more assets that the IT department's going to have to manage. So scalability is maybe the second issue. And the third then is what we've heard about this morning, which is cybersecurity. Most of the IoT devices that we're deploying are inherently, unsecure. And now let's put a lot of those out into the network, and none of us want to be the guy whose picture is in the news, right?
Yeah, so it's a big topic. So maybe, Chris, I'll ask you to comment on that. We've got new devices that are out there that maybe are easy to update to continually keep secure, as we heard about in the previous talk. There's a lot of legacy stuff out there as well. Talk about what are some challenges with taking that legacy infrastructure that hasn't aged out yet and bringing it up to modern day technology.
Yeah, so I think as you look at things like buildings and light poles and trash cans, right, they're all around cities. Today, they're not very smart. You've got a steel trash can that doesn't communicate. You've got light poles that just have a light. When you get inside the building, I think you see some challenges. Multiple vendors, especially as you get into larger portfolios, they've bought something here and another thing there. Those vendors have created proprietary communication protocols. So it's about how do you assess the current infrastructure and what are its capabilities and how does it communicate? What is our goal and our objective to get that to communicate? And then how do we help cities strategically plan out that capital improvement plan? Right, as we want to start in this building and this is how we're going to go create savings, and maybe those savings help get some new infrastructure. So I think I think it's really just around trying to make that right balance, right? And we've got to, I think the big picture talk from Sven, right, is take a step back and let's look at what we have and where we want to go.
Right. So can you or Ty maybe give an example of a case where we've successfully done this?
So I think where we've seen the most success is putting in. One of the challenges I think is there are a very few number of obvious applications that are just going to save money and give you a return on investment. So we've seen that most obviously with streetlights. So streetlight and water management, water measurement, leak detection are two of the heaviest hitters in a city's portfolio of needs. And if you could address those, with a technology that's not, a single-use proprietary thing like you've mentioned, Chris, then it becomes cheaper and easier to add the second, the third, the fourth application onto that platform. If you have to justify as the city a spend for each of these applications on their own, it's really hard to make that case. So I think in terms of challenges that we've seen, it's if the city doesn't have that bigger plan and a roadmap for what their needs are and how to execute it, and maintain that, of course, over a cycle of elections where people come and go and ideas come and go, it's hard to follow that big picture and really execute on their needs cost effectively. So it's the cities that have that plan and that really pull the trigger on the bigger applications first and make the investment up front and get the return quickly, and then it's a much easier decision to add application 3, 4, 5 down the road. That's where we've seen success.
Yeah, and this doesn't sound universal. I think every program I've ever been involved in, it's plan before you execute, right? But that's easier than said than done, obviously. So Jennifer, we've heard this morning already kind of a deep dive on security, around data, and how do you position that data so it's useful at the moment that you need it. SAS is obviously in the analytics space, and that's where this promised intelligence comes from, is into the analytics piece. Where are you seeing some of the most value returned to smart city applications? Is that things are happening more out towards the edge? Is that bringing cold data back and thinking about it and bringing intelligence later on? Streaming, as it's communicated, where are you seeing the most value?
Well, I think we're seeing both. We're seeing advantage of bringing data back and then understanding it and crunching it back at headquarters. Yep. And then we have now the advent of streaming analytics at the edge. So, you don't have to bring all the data back. You can analyze some of it, purge what you don't need, take what's really useful and bring it back and then analyze it. So I think there's a lot of opportunities coming forward. When you marry up that analytics at the edge with other new technologies like artificial intelligence, it's empowering cities to be able to do things that were not imaginable 15 years ago.
Can you share maybe a use case that you're excited about that you've seen recently?
Yeah, I think video analytics is a really good example of one of those analytics at the edge kind of married up with artificial intelligence where, for example, a Department of Transportation used video analytics to be able to identify cars that are going the wrong way. That's a simple one, but now facial recognition has become so sophisticated. You're going to see a lot of that being used in government for security purposes and other reasons.
Yeah, okay. I want to come back to that, but before we stray too far from Ty's point, maybe Jim, can you give some examples on that planning side? What have you seen or behaviors of municipalities that are more prepared versus ones maybe that need help, and those that do, like where can they find that help to know how to make themselves plug and play and compatible to smart city solutions?
As I look out into the audience, and there's Nicole from the town of Cary, right?
That's right.
So I'll say that I think where we've seen cities that really try and dig into their existing data sources and utilizing the assets that they already have deployed. Those are where we see living labs going up in Cary, in Las Vegas, where the last speaker just was talking about LiDAR technology. In Vegas, they've got this unique challenge where they have a pedestrian issue. People are walking around with their cell phone in one hand and a big drink in the other, so they've got distracted walkers. And so they've had to think about how do they address that? So maybe in changing the timing of lights based off of the crowd versus the vehicular traffic, but they really had to think that through and put up a living lab to figure those things out. So they had to find a starting place. Yeah. Maybe would be my answer, and what was the priority for that specific community.
So start with some use cases. I like the living lab concept. We're going to hear from Terry Yates from Cary. We got a few Cary people here, as I would expect, holding an event in Cary later today. So look forward to hearing some more of that. So we're in the midst of really complex technology, transformational changes as we go into IoT, this fourth industrial revolution you heard about, that is fundamentally changing the way that we do business. So Ty, working in a highly regulated industry, how do you efficiently kind of adjust to both technology changes, but then also what are you seeing in how that's changing the business models or changing the approaches in your industry? You've probably seen a lot in your career.
Yeah, no, it's a great question. So from a business model perspective, I think the challenge, and as a company that has traditionally worked with utilities, many of whom own some of the assets and sometimes many of the assets in the city that really bring value to the citizen. The challenges we've typically seen is there has never been an incentive a natural incentive for the utility to collaborate with the municipality. And it's always been we'll take care of our business and we're worried about delivering electrons or finding leaks in water system, et cetera. And that's good for the community, but sort of it's as a side effect only. What we're starting to see, certainly in the last 3-4 years, is a real sea change there. And it's an interesting development. I think it's a lot more about the utility wanting to have more touch and more reach and more stickiness in the community, be seen as someone who's not just, the lights are off very infrequently, but whenever they go off, it's I hate my utility kind of a response. Turning that around and actually providing services or enabling the city to provide services through technology and services that the utility is actually bringing themselves. So we're seeing a lot closer collaboration. A great example in this state is with Duke Energy and the city of Charlotte, for example, where Cisco and Itron have been playing a role to facilitate that collaboration between them. And that's just becoming much more universal.
Yeah, fantastic. So Chris, talk maybe building clarity. You maybe talk a little bit about what you do, but also that's a piece of infrastructure that, as it then gets sensors and things deployed that can create more intelligence, can create kind of new ways to use that infrastructure and to maintain that infrastructure than it was used before. How does that maybe parallel utility, or how is that different?
Yeah, so I think it connects. In building clarity, and what we're trying to do is look within the building and the building automation system and the lighting, the access control, all of the information, and being able to leverage that. And what does that tell you about how the building's performing? How do we then optimize that and start to improve the indoor air quality, the environment, the lighting? I think as you look at how does it connect to the outside, the utilities coming in, right? It's just trying to get that picture, right? So a ton of work being done on utilities and how it's being distributed to buildings, and we want to start to take, all right, here's what's coming in and here's how we're using it, right? So there's a good marrying up of the work that we both do to sort of get that whole picture, right? Mm-hmm. Where's it being generated, how's it being distributed, how it's being used, and then maybe returned.
Is there anything, maybe radical coming down the pipe? And I'll open to any of you. If you look at the, like the telecom industry, the broadband sector that has all this data that they can track how people are using the internet and so on, they move now into content, right? And they're buying up media outlets and things because they have the intelligence to now deliver new revenue streams in other areas. Will we see those kind of parallels? Everyone uses water in their business. Everyone uses electricity in their business. The infrastructure is owned by the utilities. The infrastructure of the buildings, these things, will collecting that data create entirely new revenue streams that we haven't envisioned from these industries before?
So from my perspective, I think there's an incredible amount of technology available today and an incredible number of use cases and applications that can be brought to bear today. I think what I do see turning, and I think this for me is really the evolution, is that we need to have is the breaking down of the silos of collaboration between groups within the city, between city and utility, to really unlock that and really bring these technologies to bear. I think the revolution has happened already. It's now how do you deliver that, who's going to buy it, how they're going to pay for it. Yeah. How does this get done with a return on investment or just an obvious benefit for the citizens that's just undeniable, and we can't hold this off any longer, because I think the floodgates are ready to open. There's a ton of value that can be put in place today, from my perspective.
So let's talk about end users, Jennifer. So you, aside from working here at SAS, you also are involved in municipal government with the town of Cary. And so how are citizens reacting to smart city solutions? Is this welcoming? It's improving quality of life? Are they confused? Tell us, their perspective, because at the end of the day, they'll be the consumers that are demanding the applications that Ty talks about.
Right. So, so I'm an elected official. I've been an elected official for about 20 years. So what we're seeing is not that citizens are even cognizant of the concept of smart cities. There's very few citizens that would say, "Is my city smart? What are you doing?" What they really are expecting are the conveniences that they receive on their cell phone, the same immediacy of information that they receive on their cell phones with different apps. They're expecting from their city. They're expecting their city to know exactly how much water they consumed, or how long their wait is at a certain traffic signal, how safe that intersection is. So they're looking for their government to know and to be able to act in a timely fashion.
How do they want to be involved in the process, or do they?
Citizens do want to be involved. We call them civically obsessed citizens,
Yeah.
and that's like 4% of your population is civically obsessed and they want to have a hand in it, and everyone else does not care unless something bad goes on. Right. They seriously, they were like, what? I didn't know that was even happening, but now that it's affecting me negatively, I care a lot.
Yep.
So that's kind of what happens.
Yeah, and I'll add that what we're seeing in the U.S. is kind of a sea change.
Yeah.
Is that we've now come to the realization that we have to have regional data exchanges. And we didn't approach it that way.
Yeah.
Right? But I'm driving around here last night. I didn't know if I was in Morrisville or Cary or Apex. I just didn't know. And as a citizen, I don't care.
Yeah.
Right? I want that information delivered to my mobile device that improves my driving experience or my visiting experience. And so that, for us in the IT organization, is going to create some really unique challenges on how do we aggregate, normalize, visualize, and share data across departments and across jurisdictions.
Yeah, and to that point, that's where elected officials have a new awareness, and key staff members have a new awareness. People were not talking about data 5 years ago in local government, and now if you attend any conference assembled of elected officials and staff members, everyone is talking about aggregating their data, finding out what data they have, and having a strategy, to Ty's point, being more organized in the way that they go about using their data.
Yeah, so let's do a quick poll. Do we have any civically obsessed folks in the audience today?
It's okay.
You folks, yeah? All right, that's at least 4%. I think maybe a little bit more, so that's fantastic. So
It would be, yeah.
I think this is I think this is a really good point. You mentioned, I think early on, Jim, that the U.S. In many ways we're behind the rest of the world, right? And one of those challenges is that kind of the siloing of every municipality has their ways that they address things, and the state has their ways, and we have these layers of government. Are there is there hope? Are we starting to see some things that enable more sharing of data, more standardization? What are the inputs that we need to push back through IIC to catch up with the rest of the world?
So I'll put in a shameless plug.
Please.
If you go to cs.co/cities,
Okay.
you can look at some of the use cases. And most of them are overseas. And what I have seen in the last 18 months is a real change across the U.S. So in Colorado, there's a Denver Smart Cities Alliance. In Jacksonville, there's the North Florida Transportation Planning Organization. Okay? I could keep going, but we're seeing these organizations form up. As we're here in the Research Triangle Park area, I would say that that's one of the challenges that we have here. I'm a resident of North Carolina.
Yep.
Is how do we compete for those jobs and visitors and citizens in our communities? And I think there is an awakening, but there's a lot of catching up to do.
Appreciate that. Anyone comments to add?
No, I think that's absolutely right, and I think what I wish there was more of, it seems to be very grassroots at this point, and it's some cities waking up and figuring out, hey, we're going about this wrong. We should be building a strategy and creating a strategy and looking at all the challenges that go with that. Where's the data today? How do we leverage it together? To identify new possibilities and new applications, and who do we use to do that? Because we don't have a staff full of data scientists ourselves to do that. And how do we share data between us? Can we do that securely? That seems to be very it's a very point-by-point type grassroots approach. I'm not seeing sort of a more sort of regulatory-led, or it's not happening at a bigger level. So you get very different approaches with very different cities, and that is a difference between here and the European Union in particular, where there's been a lot more thought and focus on, as there always is, and sometimes it's stultifying, but in some cases it actually produces results, and it's great. There's a framework where people can work in. We don't see that here. We see that much more in the EU.
Yeah. Yeah, so since Jim made a shameless plug, I'll make one as well. One of the areas that RIoT has really been trying to work on is bringing different municipalities together and trying to harmonize requirements, trying to look at, how can we help to create things that you can launch in one community, or maybe only one community needs to run that beta test or that pilot, and if it's successful, then it can map to other communities, so that not every municipality feels like they have to test every single solution themselves. And recently we've had a lot of success with US Ignite, who operates at a national level, and looking at now if we can do that here in North Carolina, we can start to scale nationally. So if you'd like to get involved in that, we would love to have anyone's participation there, and let us be the leaders in the US. I think at the end of the day, if you look at standards, and I'll invite anyone's comment on this, there are great organizations that are out driving standards, but standards are not regulations. Regulations are required. Standards tend to follow the killer apps. Mm-hmm. So you want to get people together. You want to get a groundswell of folks that agree on a way to do things and go forward. But at the end of the day, the things that everyone does, the reason that Bluetooth became standard instead of ANT Plus wasn't because ANT Plus was bad, or because HD DVD was bad, or because Beta was bad, or all the cliches. It really is, what's the killer app that gets a lot of market acceptance, and so no reason not to push that forward now. Maybe for you, talk about a successful implementation that you've seen recently that you're excited about, and that maybe we should be scaling. Chris, do you want to start?
Yeah. We looked to a project here in North Carolina in the NC Department of Transportation. They released an RFP a couple years back about trying to modernize some of their light fixtures and lighting around their facilities. So our team sort of took that idea and collaborated. How do we put this strategic approach in to work with them, try to find what the right solution is, pilot it out. So we went around and looked at a whole bunch of different manufacturers. We selected a couple. We then tested on 30 light fixtures within a way station out in eastern North Carolina. That was successful. And then it got to the point of, all right, let's go scale this. So the project is wrapping up here in the next couple months. That was over 10,000 highway light fixtures, of putting in LEDs, putting in a smart controller, the ability to monitor and sensor. Obviously improves the service level of that, keeping it at a 95%, and then there was over 16,000 facility lights, right? So it was sort of that starting small, let's go test it, and then let's go move it across. And I think that tees us up to have a pretty well-connected highway system, right? Which obviously is synergistic to what cities are going to want to be doing with the vertical infrastructure.
Absolutely. So what's the next step? So that's impressive, and congratulations on that success. I don't know how many streetlights there are in the U.S., but obviously that's just a first drop. So how do you see that scaling, and what is kind of the next step in growing that?
Yeah, so I think within the state, right, there's municipalities that have streetlights that are not a part of the highways. So how do we start to get those modernized and communicating, and then how do we take this on the road to other states? Yeah. Right. So here's what we've done and had success in North Carolina. Let's go to South Carolina and see how we start to bring that together.
So Jennifer, often in these projects, one of the the very first things that's discussed is, okay, what's the cost, what's the ROI, what is the return, how is it going to save my municipality money, or how am I going to pay back the investment, and so on. How have you seen maybe Carrie measure ROI, maybe not just in financial terms, but in other ways that are less easy to measure?
Yeah, and I'd say for governments, for local governments, ROI is more of an enabler. It's not the motivation like it might be for a company. Yeah. The motivation is quality of life for the citizens. So Carrie or any other local government is looking at technology to say, how can I improve what we do? How can we save our citizens time or money? How can we make living in our community a better place? So, and then there's objectives that they are pursuing. For example, the building management system that Building Clarity is working on with SAS. That one was actually inspired by Durham wanting to be more environmentally savvy. I think they had some standards. It was 26% or 25% energy reduction. So they were going for energy reduction. The ROI was the enabling element that empowered them to be able to pay for it and do it.
Yeah. So let me ask the same question to you, Jim, from the corporate side. We're talking about infrastructure, and so infrastructure will have an initial use case, and obviously there are financial considerations with that, but infrastructure tends to create more value over time. And how is it looked at internally from Cisco's side in terms of measuring that return on a project investment?
I'm not sure that I have a great answer for you there, because I try and I know this sounds cliche, but I try and look at it through the lens of a citizen.
Yeah.
We have investments in every city that we've got IT out there.
Yeah.
But as I mentioned early on, those investments were made without a lot of regard to how do we share the asset or the data from the asset. So I think that's the first thing, is where are we seeing these multiple use cases? We've deployed some technology, and maybe take Kansas City as the example. They're the one we always reference in the US because they've got 54 blocks that they've built out this Wi-Fi network. Realistically, it's only 54 blocks. But the Wi-Fi network that was there for delivering service to the citizen is also now a sensor for gathering data that we didn't have before.
Yeah.
So I think that's the return on investment we're looking for, is where are we delivering value to the citizens and to the customers, and then they'll take that 54 blocks and make it 300 blocks. And of course, that's when our stock value goes up.
Yep. Fantastic. So I'm going to ask a couple more questions. I do want to open up to the audience, so think about some things that you want to ask the panel. Or we got one now. We'll jump right in.
Hi. One example of a killer application would be find me a free parking spot and pay for it, and that I can have that whatever city, whatever country. And in Europe, they have the European standards of optimization, the one that does the 5G. They have said, we need to have that. To have that, we need standards. And then, from the standards perspective, there is already results there. Or as Stan from RTI said, let's put the data first. And the real killer app is the European Union, from a political standpoint, has said, if you want to select another standard, you won't get any subsidies or protected loan. So how much is this work influencing your approach in the local governments here in the US or other regions than Europe?
So I'm going to paraphrase that quickly, since we're recording, and I don't know if the microphone picked that up, but the question really is around to have kind of massive scalability, it's important to have standards so that something that's developed in one place can be used in other places, and maybe Europe is ahead in that space. And how is that reality kind of advising the way municipalities and others are working? And I don't know if, Jennifer, you want to take that?
I'll just answer from my perspective. I think that data has caught everybody by surprise. I don't think our state legislators are thinking about it enough. I don't think our federal government is thinking about it enough. I don't think that we're setting in these standards that local governments need for guidance. Certainly the interests of the local governments are not being considered by those who are making the laws. For example, the idea of monetizing data is really cool unless you're a local government and you're going to have to buy data and to run your systems. So these are elements that need to be hashed out by our lawmakers, and I don't see us doing that at this point. And I think there's a real need for this. We need more tech-savvy people running for office at those higher levels.
Great. So what are the shift gears a little bit? You say data has caught us by surprise. What is something that's coming in the next 2 to 5 years that we need to be thinking about now so that we're not surprised? Todd, you want to start?
Well, with Itron, we worry about making that problem bigger and connecting more things. So
Yeah.
I'm not going to help, unfortunately. I think that what's going to catch us by surprise is we have no idea right now. I think that's the real answer. I've been working in connecting of network devices for many, many, many years, and if there's one thing I know about it, it's I have no idea how it's going to be used in 5 years from now. So I think what's critical, and I think where a roadblock that we see at Itron to sort of realizing the value and having cities and municipalities just blindingly obviously see the value, which I think is what's going to sort of turn the spigot on to high, is how do we start all the data that's being captured today and that we want to enable more of, how do we start seeing trends and opportunities by correlating that data, which on the surface has nothing to do with one another. But if there's anything we've learned through big data exercises over the last decade, it's that it's not until you start looking and having, getting creative people looking at the data in creative ways that you see correlations, you see obvious new applications that we didn't even know were there. I think getting the brain power to look at it, getting the data in lakes so that they can be analyzed together, and getting the brain power to look at it, I think that is a key next step for really unlocking the new killer applications and the new value that we don't even know exists yet.
And I'm going to take maybe a contrary view,
sure,
right? Which might seem strange for Cisco to say, maybe less data, but if we think about it, just the deployment of IoT devices or sensors. All the DOTs now have cameras down the roadway. It's every quarter of a mile there's a camera, and it's gathering data. And we're backhauling that across fiber, and we're pulling it into a traffic operations center, and we're looking at this wall of screens. And for the most part, it's not recorded, because the DOTs don't want to get the FOIA request every time there's an accident. Mm-hmm. So if you think about that, it seems kind of strange. Why are we moving all this data if we're not going to save it? And as we start generating more and more things, and we're out saying, hey, buy 10,000 more devices at the edge of the network, that's terrific. But I think the shift for us will be creating an IoT data fabric that allows the operators to claim those devices and say, that's mine. Where do I want the compute to take place? At the edge or in the cloud? And then which devices should be sharing data with which devices? That's a paradigm shift for us in the IT world that I think we're going to deal with.
So let's dive in a little closer on that, and then I'll take a question. Because I think you bring up a really good point. And I think, we just heard Stan talk about the importance of having the ability to have exactly what data you need all the time available immediately. But you can't have all the data all the time immediately, right? And so how are IT departments going to need to change, knowing that the OT folks don't really want the IT folks messing with the sensors, and the IT folks don't want the OT folks messing with their infrastructure? Like, how are we going to have to change just structurally how we're working with all of this information?
Oh, God, I got to jump on it, because when we talk about cars, if we talk about a vehicle that's equipped with DSRC radio, right now, Hyundai, Cadillac, Audi, they've got a DSRC radio, and they're transmitting a message 10 times a second. Mm-hmm. Here I am, don't hit me. Here I am, don't hit me. Really? I need to know that 10 times a second from every vehicle equipped with DSRC radio? We can't deal with that. We're going to have a way to sample the data and say, listen, I only want to know about traction control, anti-lock braking, and airbag deployment. Give me a sample. Just give me, once every second, or just a sampling of the data. I have to have a way to parse that data at the edge of the network.
Right. Well, it's about analyzing it at the edge and then alerting when something's erroneous or anomalous. Yeah. Mm-hmm. And that's going to be huge, for a lot of functions. Mm-hmm. But just to answer your question, kind of about what needs to happen at the IT department. I talk to a lot of local governments. We are so far, maybe not the town of Cary, but most local governments are so far from doing everything right to be able to work with communicative devices and everything. Most local governments have a system that was created by their clerk's son. Mm-hmm. They have like weird wonky systems that they don't even know where the data is. It's somewhere, but they're not really sure. And there's a lot of cleanup that needs to happen. If I could ask my friends in local governments to do one thing, it would be data governance. Clean up the house before you start having a bunch of parties. And I think all these pilots are parties. You got to get your house clean.
I like that analogy. Mike, I think you got the microphone.
Yeah. Jim mentioned recording data and FOIA requests, and that brings up a interesting problem I don't think I've heard you talk as a group about, and that is privacy of the data. And ripped from the headlines, there's a number of cases where all of the major cell phone, smartphone providers have been remarketing their geolocation data and to all sorts of people, including bounty hunters, et cetera, that want to track people. But you can imagine your car tire pressure sensor, giving away your location continuously to those people in black cars tracking you, et cetera. So I'd like to hear from all of you how big a problem the industry views that as in terms of where's the balance and trade-off for personal privacy.
Who wants to jump?
I'll start. I think that's intensely creepy also. Working with utilities who take that incredibly seriously, from what data is captured, how can it be used to characterize what's happening in the home, incredibly sensitive information. The data is actually owned by us, as it's your own data as a citizen. And nobody has a right to exchange that or do anything with it without your permission. So I think that utilities have set that standard well, and that needs to be adopted no matter what the application is. And I think that's where clearly having regulations that govern that for citizens, no matter the application, is clear. And I think there's probably a fair bit of work to be done to capture that. It's with utility-centric data. It's done with other applications that you can use to derive PII or that involve PII. It's risky, and I think there's, especially when it's like as you said, Jennifer, when you're dealing as a small municipality with a homegrown IT system, and you probably haven't thought through the governance of that data to this degree. It's easy to take advantage of people and just what they don't know the risks really are. And I think that's where there's a lot more regulatory work that has to get done, because there's lots of back doors to come through. It's definitely an area of risk.
And I'll go back to some of the previous comments. You drew a nice distinction between industry standards and regulation.
Right.
Okay, so we're dancing across that border. And then I mentioned that we need to have an IoT data fabric that allows us to claim the devices and say, this one's mine. Where do I want the compute to take place, and what data should be shared between which assets? Without that type of fabric, then whose data is it? Is it the data from the person that's operating the vehicle, or the data from the organization that's gathering data from the vehicle? And I think we have to have in place a paradigm for dealing with the data from IoT before we can get to industry standards and then regulation.
Yeah, I agreed. And the opportunity for kind of open debate before that gets set, so that we all need transportation, but if only the transportation industry owns that data, then the citizen's lost, right? So that's interesting. So there's a question in the front.
Steve Rao, Town of Morrisville. Thank you for a very informative panel.
Hang on, let's grab a mic for you.
Oh, sorry. Steve Rao, Town of Morrisville. First of all, just a comment and then a question. I really applaud all of you for your great insight. And I really believe that the biggest problem facing North Carolina, and I've even told Governor Cooper this, is that the cities are just falling so far behind. There's no strategy right now on how, even if you look at Wake County, there's 13 cities, and Morrisville just hired a CIO, but Raleigh and Cary is doing most of the smart city stuff. So, Tom, I'm going to take you up on your offer on how we can really come up with more regional strategy and work with Secretary Boyette, so we really have a smart state strategy for the state of North Carolina, which we do not have today. My question is, the biggest problem occurring in Morrisville, but it's really in the triangle, is traffic and congestion, although I just got back from India with our Secretary of State, so I don't really think we have that much of a traffic problem here. But my question is, what types of smart technologies, well, let me rephrase it.
when we are dealing with rezonings, the biggest complaint comes that we have really bad traffic, so deny the development. And most of the times the solutions are road widenings, paying for more lanes. My question is, how can smart technology help address traffic flow and congestion? Are there some resources you can point me to that I can take to our new CIO to say, okay, let's Morrisville look at some smart technology? So that's my question. Thank you.
That brings to mind a quote from Fred Payne down in Greenville, who says, trying to solve a traffic problem by building bigger roads is like trying to solve obesity by buying bigger pants.
That's good.
Well put.
Yeah. So I would say, yes, there are technologies that would allow us to share signal phase and timing information between municipalities. For the most part, we see those in large urban areas, and so there's a SPAT and MAP challenge from US DOT, and there are monies coming down from the feds to fund some of those and advanced traffic management systems. So we see that as, I'll say, new and ripe opportunities for improving traffic flow, but we've got to get that down to the counties and to some of the smaller municipalities. And it's a mess. Mm-hmm. You know, you talked about the streetlights. Who owns the streetlights? Do the utilities own the streetlights or the cities? And the same thing with the traffic. Do you run traffic ops, or does the county, or does the state? And so this is where, our democracy makes it a little challenging, but the technologies exist. It's a matter of going back to the planning and design to figure out how we solve the problem, I think.
Yeah, just to add to that, I'd say, so we've certainly, partners of ours have delivered traffic management and traffic flow solutions on our platform. The challenge always comes, and I think this is a great, as a Triangle resident myself, Morrisville has a traffic issue because there's an accident in Cary, or there's something going on 40. And so when you look at it's Durham County and Wake County together, that it's a system that spans, it doesn't observe city boundaries, it doesn't observe county boundaries, it's a regional problem. So you have to have a regional solution to address it. So that collaboration is absolutely critical. You can have the smartest infrastructure in Morrisville that you want, but the moment that there's a problem on the way to the airport on I-40, you're in trouble.
So I'm going to break the moderator rule and offer an answer as well instead of just asking you questions. I think one of the things that isn't being talked about enough is what you heard earlier, that that people aren't getting driver's licenses. Like, the whole idea of transportation is changing. And if we keep thinking in terms of how do we reduce congestion, how do we build better roads in the right places, even the instrumentation of the roads to understand where the vehicles are to hopefully make them run more efficiently, I think at some level that's the wrong discussion. I think that in the way that municipalities have always said it is our role to provide roads, that was really a way of saying it is our role to provide transportation. And the market dynamics at the time, where people bought cars and then they used their personal cars and so on. And as that's not happening, I would challenge municipalities to say, we are going to fully own transportation, which means owning the roads and owning the things that are moving people around. And as people are no longer driving themselves, we can stop having 3 empty seats in every vehicle as a car is moving around, in an autonomous shuttle that is maybe a part of a fleet operated as a transportation network for a city can have 4 people in every car and reduce congestion dramatically and so on. And so thinking in terms of what are the things that my municipality can do to enable the coming autonomous shuttle form of transportation. How can we allow the scooters that have proliferated like rabbits all over town to be out there as alternatives? Things like that, where you're embracing kind of new change versus trying to just add technology to the old way.
And I would add to that, when you talk to a bunch of elected officials, people have changed. Their conversation has evolved as well from transportation and roads to mobility. And we're talking about mobility and how can we move people and goods. And so there's a lot of transformation of thought. But as the question is, can our regulations and standards keep up, with the technology opportunities out there?
Yeah, interesting.
Steve, my only answer is I think you need to be in the 1:30 session about intelligent transportation systems.
It's great. Question over here.
I think related to the previous question, is there a benefit being realized by municipalities to crowdsource citizens beyond the 4% super citizens by developing like a municipality app? Let's say that when you enter into Raleigh on my smartphone, if I'm on Facebook, it says "Welcome to Raleigh." Here are local restaurants. Instead of just having that, could it be like, join our municipality app, which has information about the cheapest gas stations and traffic flows and parking spaces, things like that, but also provide an opportunity for citizens to say, hey, there's a pothole here, or there's congestion here, or we really need a better this or that, and then collect that into a shared database or something like that, or maybe localized. So that you really have on the ground information being gathered that's specific to that locality, but also can be shared where it's beneficial for the broader region.
Yeah, I would say yes, absolutely. And the person we should have on the panel here is probably the CIO from Cary, Nicole. But I think local governments are moving towards using a lot of crowdsourced information, and there's a lot of value in that. So I think as technology opportunities advance and an openness grows among governments to have that kind of feedback from their citizens, you'll see a lot more of that. I remember, and I don't remember how long ago, but we'll say 12, 15 years ago, where the town of Cary was afraid to have a Facebook page because we weren't sure what people were going to post on it. And so you think about how far we've evolved, that we're seeking out information in the form of crowdsourcing. We've come a long way.
Yeah, I like that idea of kind of sets of data as infrastructure. And not just thinking about physical infrastructure. That's great. Other thoughts or questions? Let's go right here.
Philip Knight with STG Systems. You have been talking about basically a lot about fragmentation of standards and how that impedes things. And I guess if you talked about it in terms of particular industries or verticals, there's probably a whole set in every one. My question is more general than that, and I'll use an example. TCP/IP lets us do pretty much everything we've been talking about. Are there any areas of standardization with the advent of IoT that are analogous to TCP/IP in that they span multiple industries, pervasive, where things are fragmented in such a way that it's really impeding innovation at this time? Can you think of any that fit that category?
I'm not really expert.
There are a few things that are developing. You've got Open Fog over here. Right. Cisco's working on a consortium for IoTopia, but these are all really early stage. Right now, where we are, the water guys have theirs, the transportation guys have theirs, public safety has theirs, and these are still separate.
I think at some level, like even if you look at like home automation as an example, right? There were points where we thought Zigbee was going to be the thing that everything went towards, and there was a groundswell that direction, but it never really took hold, right? And so you have real, kind of lower level, the way MQTT works or CoAP or other things. But I think we're still really waiting for that killer app, which is about scalability. There are incredible solutions that are out there, but they're not scaled to the level yet that everything else just falls in line. And that's a little bit of kind of natural market dynamics, I think, when you have new technologies that come out, that it starts as the Wild West, and then there's a bunch of gun battles, and over time we consolidate until we have a duopoly or whatever we allow here in the U.S. Any other thoughts or comments on that?
I would just say, as far as the work that we're doing with local government, one of our biggest challenges is having solutions that are priced appropriately. we can do all kinds of things if you have unlimited funds, but governments have limited funds. So I think, Chris, you were talking about, you know, the repeatability of a solution, and that's where we're going to really see things scale up, is when we can hit that price point right for local governments.
Yeah, okay. I think there was a question right here.
Thank you so much. This question has more of an international spin to it, and the gentleman was talking about the EU and standards. If the US is just getting into the IoT space and areas across the world are already steps ahead, are you guys reaching across borders, international boundaries to collaborate with people that are further down the path? Or is this all, you know, US centric?
Yeah, and I'll say we've been talking about public sector smart cities on the panel here.
Right.
I think we really have to change that conversation a bit when we think about this from an enterprise perspective. So the industry standards that apply to an industry are more global. So I don't want to confuse this conversation that this has been mostly about public sector, and so there's just a slight twist.
Well, and I'd say also that that we're not behind in the U.S. in terms of industrial IoT.
Right.
I think it's easier applied in some other countries. Itron has deployed a smart city platform in Singapore, for example. Singapore is a great place to do business in because it's a dictatorship, and if they make a selection, you go forward, you deploy, there's no fussing around, it's done. You may not want to live in that environment, but it's a great place to bring technology to. So the rate and pace of deployment in some other places around the world is faster. But I would say that many of our most advanced deployments are also done in this country. So,
yes.
And it's interesting that there's not a lot of difference between the needs of cities globally at the sort of the top few real big bang for the buck applications. It's streetlight management. It's almost always water management is number two. Then it's, and everyone has traffic problems. Everyone has parking problems. After that, it gets a bit more interesting and diverse depending on the regional need. But I think the good news is we shouldn't feel like we're behind in this country. And I think what would be beneficial though is a lot more collaboration between municipalities around the world to see some of this where, hey, we're not that different, and maybe we could collaborate to define standards that are global and practices that are global, because there's not that much difference, frankly, that I've seen anyway.
Fantastic. Question here in the middle.
Thank you. Joe Malazzo with Regional Transportation Alliance here in the Triangle Market. This is a slightly different question. It's hard for those of us who aren't on the inside of it to keep up with everything, but one thing we notice, certain things go faster than we think, some things go a little slower, take longer. What is something that's happened, let's say in the last 2 or 3 years, where it either went in a completely different direction than you thought? It doesn't have to even be standards, it can just be a technology or an implementation, an application where you thought it was going to go one way, then all of a sudden something happened, something disrupted it, or technology increased at a faster pace, or something else happened the other way and it didn't get picked up as quickly, and and how did that go? Or if neither of those are there, what do you think that we're not paying attention to that we should be? It doesn't have to be transportation.
No, I think transportation is a good one. So I would say that in terms of standards, you were talking about Bluetooth, VHS versus Betamax.
Yeah,
right?
yeah.
So there's that debate about DSRC in vehicles. And when you're trying to predict what the industry standard is going to be, and you have manufacturers like Cadillac jump in and say it's going to be DSRC, but then Ford jump in and go, no, it's going to be 5G. And who knows? It's going to be millimeter wave, or it's going to be whatever. So I think that's part of the challenge that we're dealing with is just the new technologies. When you saw that slide earlier, and the revolution took this long, and then this long, and this long, and now the cycles are just so quick. So I'd say it is trying to. Who put up the Chambers quote? I was in the green room when I saw that. And I was like, yeah, that's it. That's the problem, is trying to catch that market change and figure out, is it going to be Bluetooth or is it going to be something else? And in the transportation space, that's definitely the challenge.
So there is one thing that I think is fundamentally accepted as an infrastructure piece that is required, though, which is broadband. And if we look at transportation, for example, any thoughts on how we solve this issue that once you get out of the urban centers, how are we going to have the broadband necessary for that application and all the others that happen? That's something that maybe hasn't changed on the pace, to your question, that I would have expected would happen.
And it's different state to state, depending on the state regulations.
Right.
Because we were impeded in North Carolina to advance the expansion of broadband in smaller communities because the state said that local governments couldn't run their own broadband. It had to go to a company. Most companies don't want to go to Selma, North Carolina, because they can't make any money there. So we have to look at this on a statewide level.
Yeah, and I'll say for those that do want to be those radically involved citizens, or whatever the term was we used
Civically
earlier,
obsessed, yeah.
that's an area, at least here in North Carolina, that speak to your legislators. We need to get that fixed. I think we have time for one more question. Over here.
So with the proliferation of all these technologies, there's obviously some pretty severe security implications that can come out of this. I know in the energy sector, you've got regulations on NERC-CIP and NIST that kind of provides frameworks and guidance. But as we go into smart cities and start to look at things like streetlight automation and traffic flow automation, what are the communities doing to ensure that these devices, both at the device level and the supply chain level, are secure so that they don't become a threat vector back into other systems or begin to attack the community as a whole from a cybersecurity standpoint?
So I would say that that's very much dependent on vendors that are selected to bring the technology today. So it's because like you say, there's not a NERC-CIP equivalent in smart city applications beyond those directly related to energy. So it's a lot about vetting your vendor that you're selecting to deliver a capability to make sure that it's in their solution, which is challenging to do, obviously, for smaller municipalities who just don't have that savvy. But there's certainly not at this point anything like a standard or standards that apply to applications beyond energy and utilities applications today.
All right, thanks. So I think we've got about 5 seconds by the clock on the back. Real fast, 3 words or less. What are you most excited about talking about next year in smart infrastructure? Jim? Whoever wants to jump
Artificial intelligence.
Artificial intelligence.
Artificial intelligence.
All right.
Thank you.
That we've solved, and we have a national infrastructure of regulations that now govern all of these problems and challenges for us.
All right.
Scaling.
I love it. All right, let's thank our panelists. All right, good job. Good job.
I'd like to thank the panel too, and I know that Urban Systems Foundation would have loved to be here to talk about open standards and open source to implement smart cities. Take a look, Urban Systems. And by the way, the call for tech-savvy politicians, I don't know, they end up using Twitter. We're going to take a half-hour break now until 11:15, and please take the time to go take a look at some of the exhibits that are out in the hallway. Thank you very much. Ladies and gentlemen, can I have your attention? We're going to get started again. 1 minute and 30 seconds late. Ladies and gentlemen. Ladies and gentlemen, and Sven. Thank you very much. We're going to get started again. We will be taking another break for lunch at 12:15. But we've got a couple of quick sessions before then, half-hour sessions before then. At 11:15, it's now close to 11:15. We have the keynote from our host, SAS Institute. Jason Mann and Anne Perreault are going to talk about value generation in the IoT ecosystem, and we hope that they're in the room because they, not right here.
One of us is here.
At least one of you is here.
How are you doing?
Very well, how are you?
I guess I can still say good morning. It's not quite twisted over to noon, so good morning, everyone. And welcome to the IIC members. Welcome, I think, again, to the RIoT members. I know we hosted an event just a while back. I'm very excited to be with you here today and talk a bit about a representative initiative around value generation from the Internet of Things and one with a partner. I think they left me a, maybe they didn't. Yeah. I think you may have taken the clicker. We can talk to this slide for a while if that would be better. All right, thank you. So first, just a couple of quick slides about SAS. I'll keep this simple. And it's really about our mission. Empower and inspire with the most trusted analytics. You'll find that nearly everything that we do is in alignment with this overall mission. Today, you are with us here at our global headquarters. SAS has a little over 14,000 people, roughly distributed equally across the globe. You can see the spread there. We have 6 development centers that are also spread across the globe in Pune, one here in Cary, Japan, missing a couple others that are spread out. If you talk about the IoT market in general, we really look at the value generation opportunity there broken across 3 separate areas. We truly believe that it is an analytics opportunity, the idea of transitioning from a data aggregation project into more opportunity for insight and decisioning on autonomous engagement. Here at the company, we think that it's a channel opportunity, recognizing that with the establishment of these external ecosystems and the business models that channel plays go very well with the additional value that analytics can provide. And finally, perhaps the most important one, and certainly one that RIoT and IIC deal with, is the idea that it's the ecosystem. So the broad network of install base, networking, communications infrastructure, domain, all are parts of the ultimate value that can be presented to their end customer. So what I'd like to do today is spend a couple of minutes and talk through an example that really merges all 3 of these initiatives. So light switch, I can't think of anything that we take more for granted than energy, electricity. We flip a switch and we just assume the light or the device is going to come on. Very little thought is given to what happens in the background required to deliver this energy, electricity, safely and reliably. What most of us may not realize is before it gets there, it most likely originated from a vast network, in this case, the U.S. or national power grid. This is about 200,000 miles. We'll start to take in the scale of our power grid. 200,000 miles of high voltage transmission line, just in high voltage. Another 5.5 million miles of local distribution lines. So as you might imagine, it's a huge expense to keep these lines open and clear. One of the largest risks to reliable power delivery is concerns with contact with vegetation. Again, you start to think about the scale. 35% of the operating budget for utilities is spent on vegetation management. To give you some context for that, local utilities, the independently owned utilities just in California, spend $250 million every year on vegetation management. That's just for the high voltage lines. So you start to see the scale of the problem that they have to deal with. Now, for the longest time, and really going back 100 years, it's been a pretty consistent process that they've addressed this concern. They roll trucks, they roll people, they do a manual inspection, and they clear cut. And usually it's in time cycles, every 3 to 4 years. There's also a significant regulatory impetus in these industries. While it's quite hard to move the top line, they can't just increase revenue without an extensive approval process. They are tasked with modernizing the grid. So they have to invest in infrastructure, but they really don't have a lot of top line variability. So they really have to focus on ways to be more efficient with respect to the cost side of the equation. And if you're constantly spending $250 million a year on vegetation management, it is quite difficult to invest in those top lines. These regulatory requirements, they give you a requirement, but not necessarily a mode or model to get there. So why is it so hard, right? It really is about variability. You think about the types of weather, topology, region, plant species. They constantly have to deal with the variation within their market. There's things like storms and overall storm damage and drought and fire. So all considerations that they have to deal with every day. So with this high variability percentage, what do they do? So anyone recognize this? I know you didn't figure you would have an arborist training class today, but we're going to spend a couple of slides on this. This is an oak tree. Certainly, if you're from anywhere in the South, you recognize this. Not a huge problem, right? It grows about 80 feet tall, 80 feet wide. It grows about 1 to 2 feet per year. Pretty easy to plan, right? So if this was your only problem, it wouldn't be a huge issue. Anyone recognize this picture? Yes. This is at the other end of the spectrum, right? This grows near a golf course where I play a lot. It owns about 100 of my golf balls at a minimum. But if you start to think about the impact of kudzu, as many of you have identified, it grows 1 foot per day, right? Think of the difference in that, a foot per year, a foot per day. Millions and millions of dollars are spent every year just on the impact of kudzu into your power grid. Today, just in the South, another little trivia point, 7.5 million acres are covered by kudzu in the Southeast. So quite the ornamental plant, which is where it got its beginning. All right, one more example. Evergreen tree, pine tree. You think, oh no, not the pine tree, that's a Christmas tree. How can that be a big issue? They grow, 150, 200 feet tall. But what you may not know again is pine beetles love pine trees. And in the South, they are an invasive species. An infestation in a pine forest can spread 50 feet per day. So as you start your planning process on vegetation management, you're not considering the 1 to 2 feet that it may grow every year. Now you have 160 feet of tree that's going to fall into your right-of-way or into your power lines. So while, again, we're spending a little time to provide context, it goes back to the root of the problem. High variation, right, on what you're planning against. Gigantic install base, 200,000 miles, 5.5 million miles of local distribution that you have to plan for. Luckily, there are companies that have emerged to address this concern for the utilities. If you may be familiar with Honeywell, if you look back, long history in the manufacture of drones, vision, both photograph and video, aerial photograph and video, huge investment in that. And they've created divisions targeted leveraging their expertise in manufacturing to provide a service into these entities that need a new way to address this overall problem. Just recently, they've partnered with SAS to expand the overall value of those initiatives and to try to help with some scale and accuracy within their services environment. So I have a video that kind of depicts some of this, so we could start that. So the process today, a lot of times new technology will emulate the old processes, right? So today they're going to pair a licensed pilot. You still have to have a licensed pilot to fly a drone. They're going to bring in a domain expert, whether it's an arborist or someone from the utility, and they're essentially going to do a flyby, and as they fly by, they're manually identifying areas of concern, vegetation encroachment, certain types of vegetation growth concerns. I think in this case, as it moves through, you're identifying the severity and the urgency and the time scale that you need to address that. Now, if you want to expand that scale, you then start to understand how can I leverage that very same investment in the drone technology and use some capabilities, analytical capabilities like computer vision and object detection, object identification, and then start to bring in third-party data sets, things like projected growth rate and weather impact on those growth rates, topology, region. And you're starting to be able to calculate at scale these risks. Now, this is of critical importance to being able to move those levers within the utilities because, again, they have very limited opportunity for top-line growth, and you really have to be able to adjust the cost picture. And being able to expand the value of your solution expands opportunities for both top-line growth for Honeywell to the utilities, and in the end, a reduced picture for cost, addressing costs on the back end. So let's talk about what we just saw there. At SAS, we oftentimes refer to the analytics lifecycle. It's not unique to us, but it's certainly something known to the market. But sometimes you lose track of what actually happened when you see these types of videos. So at the top, data. There's a mix of data. There's streaming data from the drone itself. There's enriched data from weather inputs that you're having to buy that can oftentimes be really drilled down into small geofence loops. There's calculated data. We talked about the growth rate. So the growth rates are going to change. There's an algorithm that is generating those projected growth rates. So important to have that element covered. Then expand into discovery, the modeling itself, whether it be incorporating something like YOLO, you only look once, some of the open source video training routines. But more importantly, the ability to continue to maintain and advance the creation of the models over time. The fact is, data models change, use cases change. You have to have the ability to sustain at an enterprise level the development and deployment of these models. And then that goes to the very last point, the idea, the concept of deployment. Edge to cloud, all the way from these small footprint, small compute devices where you're executing some of the score code, or in more of the cloud environment or persistent environment where you're building and managing the models. So what we found is being able to support this full analytics lifecycle is the path to sustained value. So at this point, I have the privilege of inviting to the stage Ann Perreault. I think she's back there. Ann? Yes, yeah, she's out. It's working out. So if you could please come join us. They told me to sit in the middle. I'll call this the middle, and
Okay,
I'll be to one
perfect.
side. So thank you for joining us.
Absolutely.
So Ann, I think many people in the crowd certainly recognize the Honeywell brand and the name. They may not know a little more detail about what you actually do around smart energy. So pull the slide up. Could you cover a bit of that?
Sure, absolutely. Appreciate the opportunity. So I know many of you are probably very familiar with Honeywell as a household name, thermostats, HVAC, and other areas that help with quality of air. But what we do within smart energy and the larger portfolio of Honeywell is actually, I think, really an exciting time for us. We're a well-versed company across many different verticals. If you think about Honeywell, actually, you probably don't realize that 60% of commercial airplanes are Honeywell technology. Buildings, over 10 million buildings worldwide use Honeywell control and automation technologies. Homes, very similar, 150 million homes with similar type control and automation. And so really what we've done is within smart energy is been able to leverage that broad vertical and industrial insight that we have from sensors, control, and automation that we deliver today and brought that into the energy group. And we serve utilities as a technology enabling platform and a partner to help them globally. And today, I think what we're doing, which is so much different, is really helping enable that transformation to technology companies. And so as we look at that, it is really about, from sensors to metering to monitoring and all those edge controls to cloud and systems that drive automation and intelligence at the grid.
All right. And then what about the ecosystem?
Yeah, and so I just wanted to highlight this because it actually came up earlier, and I think it's a really important component of how we all drive really this evolution or revolution across IoT or IIoT, is that ecosystem of how do you actually get there. And so for us, our approach is very much meant to be very flexible, because the one challenge that we have that is probably the greatest, and I think there's other industries that face it, but you have an enormous amount of infrastructure, right, that is already deployed. I mean, legacy infrastructure that you can't rip and replace. You can't change it all today or tomorrow. And so how do you drive automation at the various levels that have the greatest impact? And so for us, it's a focus on how do we increase resiliency, reliability, reduce outage, improve operations. And we can really do that from edge to cloud because of the approach that we take and how we're working with utilities.
Oh, fantastic. All right, so off to a couple other questions. I know when I was looking at the problem, that was put forth, I was shocked by the idea and the scale. 35% of operating budget. There's very few businesses that you run into that have a singular problem that represents that much of its budget. So can you tell me a little bit about what was the driver to enter the market? Obviously, a huge opportunity there, but what was driving Honeywell's decision to enter the service? And tell me a little more about that service offering.
Sure. It's a great question because I think many of you might go, Honeywell and vegetation management, how does that go together? So we actually had to pause and think about that too, but I'll tell you this. So a couple of things that actually helped accelerate and drive that is that we launched a UAV service with our aerospace team. So in partnership with that division, we were able to take advantage of that. They were going out on the supply side, on the generation side, and now even on the utility distribution side and providing services to provide insights to infrastructure. And as we started to work with our utility partners, we quickly learned that the amount of data that we were presenting and providing, while helpful in terms of identifying issues, one of the biggest issues they had was this vegetation management. And so it was really exciting for us, I think, to work. We very much listen to our customers because I think one of the things that's easy to do is you go, we have all this technology and all this data. There's so many things that we can do. But when you think about 35% of a budget being spent on this vegetation management, sending trucks, kind of randomly into spaces that may have overgrowth, such an underserved need or just a huge issue, huge cost issue. And so as we listened more, it became apparent to us that we had an opportunity to really help optimize that and not just deliver the feedback from those flights, but actually optimize what they do next.
Oh, fantastic. All right, so let's pivot the conversation a bit. I think some of the earlier presentations talk about edge or reference edge. Edge has been a significant area of investment for SAS over the last couple of years, but oftentimes I don't know that it's truly understood. What is it? And I guess the first response is, well, it changes, right? The definition continues to change. But if you look at the opportunities that it provides with respect to latency of decisioning or compare and contrast to the old way of moving batch processes back into a server environment, can you tell me how the availability of edge compute addresses your business, your service, and how it provides some differentiated value?
Sure, absolutely. So much of what you think about in terms of utility resiliency and reliability is about what's happening at the edge. And so, I think with the incredible power of compute, not even just a few years ago, so much of, I think, the problems were being solved or being looked at the cloud. There was a lot of focus on the cloud. You start to look at, again, this legacy infrastructure, legacy systems, and you go, how am I going to get there fast enough to actually reduce outage time or even prevent an outage? And so, for us, I think the reality is that there's an enormous amount of capability at the edge. And what you can do with that in terms of, advanced analytics really gets into, there's a lot of problems you don't need to solve back at the head-end system. You just need to report the anomalies or the exceptions, right? So when we're looking at things like power quality, there's an enormous kind of range, hundreds of use cases, if not more. And I think we've probably just started to tap the potential of where that can go. We are looking at data that, line sensors, transformer monitoring, substation monitoring, all of these different elements of grid resources, and then using analytics to solve problems there locally and bring back the exceptions.
Right, so maybe extend that point. So the idea, we're today just talking about vegetation management, but you're really servicing many of the use cases within the utility. Can you expand a bit on other opportunities?
Yeah, absolutely. So for us, it's really grid automation and grid intelligence, right? And so that's a lot of that ends up being how do you reduce costs, improve distribution, that reduce outage. And so those are a couple of key areas, I would say. So if I think about it at the utility level, those are some of the areas that drive the most value to the utility, right? Is when I can provide those insights and use even analytics to prevent it. One of the areas that we're able to do that, we're leveraging even on the buildings and on the plant side, where we've got predictive insights into potential failures, machine or plant failures that we're actually able to transfer into utility operations, and from there, help predict and prevent those types of issues. At a customer level, so again, leveraging our commercial and industrial verticals within Honeywell, we're able to bring additional insights that utility can take to their customer and help improve operations, reduce downtime at the customer level. Those are other areas. And then, the consumer is one that's been probably focused on, and maybe some of you have experienced this. There's a lot of data now that helps you improve efficiency and helps you understand even, maybe more where areas of maintenance or areas of improvement can be, considered at the home. So there's a lot. It's an untapped potential.
It's
it
been
really
a long
is.
time
It's
talking about
very
that.
exciting.
Sure.
Yeah.
All right, so one other question. I know we were going to set some time aside to answer some questions. From a SaaS perspective, we talked about the ecosystem and the importance of being able to plug into those. When we're talking with our leadership team, we really have a triangle that we draw, right? Where can we be successful? And for me, it is when you have a clearly defined SLA in place, and whether those commitments are internal business units or whether they're to your final end customers. So that has to be firmly in place. We really look for the ability to deliver differentiated technology. So how can we provide a difference? And then finally, domain. And domain is I think it's the path to transition the discussion from this very high level, what can IoT do for me, to what specific outcome am I going to deliver to the business? So when we put those three questions together, that's kind of an opportunity for success. When you're looking at partners to incorporate into your ecosystem, what are the criteria? Or can you tell me a little more about your selection process?
Sure, absolutely. So one of the things I would just emphasize is the importance of the ecosystem as a whole. That not one company is going to solve all the problems, as much as maybe I might like that, if we could. But no, it is truly an ecosystem approach. And so when we think about partners and how do we continue to enable the innovation and the acceleration of adoption, because that is one of the keys, is the adoption of the technology and getting out of the playground and the pilots and truly moving forward, is really looking at, probably not too surprising, but looking at things in terms of size and scale, cyber, data governance policy, ease of integration, ease of working together. I think for us, utilities are so highly regulated, so risk adverse. It's a challenge in terms of to their legacy systems. And so what we're really doing is when we look at those partners is, how do we bridge that gap? How do we take the existing maybe lack of granularity or lack of data and just pull that all forward in a way that we can present it, in solutions and offerings that really make a difference. And so I think, those are key areas that we look at that help us.
Fantastic. And thank you so much for coming to join us. Thank you to IIC and the RIoT teams for allowing us to come in and participate. I think at this point we have a couple minutes that are available for questions. This will make it quick. Yes.
Talk about your respective ecosystem models for bringing technology partners into end-to-end solutions.
Right, so I think that's part of, at least from SaaS's perspective, what we're looking for is where can we provide a difference through analytics. We are not an IoT platform, we are an analytics platform. So what we're looking to do is identify those opportunities where we can increase either the top line growth, right, provide additional services in these customer-facing ecosystems, or many times also reduce the footprint and the cost. So it is an evaluation. Normally there's some association with a high capital installed base or a high capital problem, such as we've identified with vegetation management. So from my perspective, it's about identifying real value and outcomes. So I don't know if you want to extend.
Yeah, I think I would just add to that, for us it is a defined, for sure, ecosystem and stack. So it is, we've defined 7 layers, but simply it's, edge, connectivity, and then the software, and it's really not meant to be applications at the top, but it's, from a stack perspective, looking at it that way, because it can sit right at the edge. And I think for us it has been designed really specifically to say not only can our edge applications or our systems be a part of that ecosystem, but so can companies that other partners that wish to participate can be a part of that. So it's really designed to be open and to really accelerate, I think, where innovation can go.
Yeah, I think that's a good point. To close the ecosystem, inability to consume some of the open initiatives, that's a dead premise. You really have to have that plug and play and really focus on not being a displacement technology and continue to add value on installed base. So. Anything else? All right, well, thank you so much, and thank you.
Thank you.
Thank you very much.
Clicker.
I need that. So before we break for lunch, we've got two quick presentations that are case studies. So real systems that have been up and running and built systems. Our first is improving response time and customer experience using building automation systems. That's Terry Yates, PMO and Smart City Manager for the town of Cary, who hopefully is right here. Thank you.
Thank you. Thank you. Hello, everyone. So my name's Terry Yates. I'm the Smart Cities Program Manager at the town of Cary. And basically, I'm going to be talking about our building automation system, kind of the history around it and where we're headed, present and where we're headed. So three key takeaways from our presentation. We're going to talk about the reactive past, where we were, and then as we move to a proactive present and then a predictive future. And we'll step through that, how we made improvements along the way. So, I've been in Cary for 17 years. I've seen a lot of change. In the past, we had no building automation. Basically, if you were a citizen or you were an employee and you were in our facilities, and let's say the temperature started getting hot, you would call somebody, they would send out a technician, they would adjust, they would find a problem, they would adjust it, they would leave, and then a week later they would come back to test, make sure everything's working fine, or wait on another call. Very inefficient. So we were looking for ways to improve efficiency at the town. So it all kind of started in building the foundation. And a lot of these things that we talk about, that the panelists talked about this morning, I'm kind of going to build on that because everything that was talked about has kind of been our journey in building automation and improving that experience. So the first thing was connectivity. In 2001, through a DOT grant, we ran fiber to all of our traffic intersections. But while we were doing that, we hooked up 22 of our facilities on our fiber network. And we established somewhat of a standard where every time we build a new facility, within reasonable distance, we add fiber connectivity. It's much like a utility. I think they were talking about broadband being essential for smart cities and IoT. And so when you think about broadband, running fiber to all of our facilities is a key foundational aspect of that. So standardization. A lot of talk about standardization. And when the discussion about standardization, more from the town of Cary standpoint, is having a product that we're going to put in every single building to establish connectivity for us to be able to see insights into our buildings. So around 2009, we started putting tritium chase units in every single building that we constructed. And what that does is, with the fiber connectivity, putting these JACE units in, we were starting to able to log into the facility remotely, see what was going on with issues, make corrections in the systems. And when I mean systems, lighting, power, utilization, HVAC. So you were able to log in and get some insights in that building and make some corrections. However, there are a lot of problems with just having a connection into the building. We talked about security. So every time I put a JACE unit in, I got to load in credentials, make sure security's there. How do I do updates? Can't do updates. Don't have any centralized place to send updates to the units. Data collection. How am I going to do data collection? It only holds so much data. So then, I've got to log in, pull the data manually, and I might not be getting all the data that I really need. So there was a lot of, a lot of initial issues with that. And as we added more facilities and more facilities, it became harder to manage. I'm logging into every single building. And alerts, we didn't have a way to get alerts when we had problems and stuff like that. So we moved into basically the proactive present, where we, in 2015, we installed a centralized building automation system. It's a Niagara system that was put in, and basically it interconnected all of those Yates units together. It allowed for some security to be put in place. We attached that building automation system to our Active Directory. So now when people are onboarded with our facilities department, they get credentials on the system automatically. They're provisioned that, so addressing security, addressing updates, pushing updates down to those Yates units. Getting data collection. So now we're able to collect more data. We're able to see how all of our facilities are operating together. A lot of the things that the panelists were talking about this morning. If there's a problem, we can get a visual of what's going on in our buildings. Visuals of what's going on in our buildings, and technicians are able to respond much quicker. They can bring up the dashboard, they can make corrections, they can set up alerts and all of that. But some of the challenges we have with that are, how does it work with other systems? How does it notify people if they put a call in, they got an issue, you're waiting on a phone call. You're waiting on a phone call for citizens using your facilities, you're waiting for a phone call from our public works folks that there's a problem, or our other staff that there's a problem. So you've got that issue. And then when you fix the problem, how do you notify everybody? So, those are the challenges. And then how does it interact with our other systems, security systems? Let's say somebody wants to come in on the weekend, and if we have a schedule running during the week from a building efficiency standpoint, and they come in the building, we want an automatic notification that somebody's in the building, because nobody's supposed to be in the building, but somebody may come in to work on the weekend. So we need to adjust our systems and schedules for that. So that's where I get into the kind of the predictive future. And with the predictive future, we have automated response. So automated response means our next step in our journey is to establish a connection between that building automation system and our CRM platform. We're moving to Salesforce for all of our work orders. So a work order about a light bulb, changing a light bulb in a facility, will be on the same system as getting a notification from our building automation system. And we don't want that technician to have to put in a ticket, fill out all the information, look at the specs. We want all that information flowing from the building automation system into the CRM platform. So, we're on this journey. We're looking to establish a connector between our building automation system to Salesforce. Also, having that connector will allow us to send it to other locations, like your open data portal. Let's say we want to share some data, share some data with citizens. How efficient are our buildings? So we send that information to our open data portal. I mentioned the security standpoint. I want to integrate it into the security system so that when somebody walks in the building on the weekend, it talks to the building automation system and says, hey, there's somebody at our facility. And we're going to adjust the temperature, and maybe we know what office they're in. So maybe we just need to adjust the temperature in that office. So the other thing is creating that notification. So having a centralized way to notify everyone, we send an automated ticket to that technician that goes out, if he has to go out. Maybe he just logs into the system. Send that notification to our 311 center. Send it to our 911 center. Maybe if we can tie it into the Wi-Fi system, and the citizens in the building, we can send an alert to the citizen that, hey, there's an issue with the building automation system. So that's what I talk about when I mean automated response. We want to automate the response. We want to get a better customer experience when you come to our facilities to do business. to have a Parks and Rec activity or pay your utility bill, and with staff working in a conference room. And then analytics, we talked a lot about that, having data coming from not only the building automation system, having data coming from our transportation systems, or let's say we want to pick up weather systems, weather gauges, temperature gauges, so that we can tie the information from the temperature outside to our building automation system. And send that to SAS and let SAS analyze it and say, hey, how can we better use our facilities, make them more efficient, save money that we can fund those IoT projects and those smart city projects and other things that we want to do. So that's kind of where all the tie-in and that having a connector in place to connect all of those things together. And then why are we doing all of this? It's about the customer experience. We talked a lot about it. We talked about our citizens. We talked about our staff, our community. It's all about the community experience, the customer experience. So that's what we're doing all this for. And with that, that's it. So. I got time for a few questions. All right. Yes, sir. Yes, sir.
On your security integration, has that been going in parallel, or is that just being bolted on after you get to the predicted future?
So from a security integration standpoint, so right now it's like I said, we've got our Active Directory is integrated into it. With predictive future, then we'll be looking at, well, how do we tie those other systems? Part of smart cities, one of the things through our smart city journey is as we look at, first of all, Jennifer mentioned like cleaning up your house. The thing we embarked on was we went on a mission to identify every system of record, every application we have, so that we can see first if you've got five applications doing the same thing. So maybe you only need one application. So you address security that way. You consolidate these applications down to one application. So then you're just addressing security on one system. And then if that system needs to be replaced, there's some key things. It's got to integrate with Active Directory. We have to have a SAML2 authentication with it. Sensitive data has to be encrypted, has to be stored in a location where people can't access it. We have to have an API. We talked about a connector, having an API on those systems. That's going to be a heavy requirement, a modern API, so that we can pull data in and push data down. And by consolidating and getting your stuff in order, you can handle data management, and then you can address security, and you don't have all of these systems like a spaghetti of systems that you're trying to handle all the security. So that's what we've kind of done, getting to that predictive future for now. So now I'll be implementing that. So, all right.
This is a little bit outside what you spoke of, but in the same respect. It came up earlier. I was hoping maybe you can describe what the city of Cary and yourself is doing with regards to Duke Energy, demand side management, rate, the communications of rates, real-time rates, other things with regards to, because you guys don't run your own electrical utility, but you also have all these homes and buildings. I mean, you've done a great job in describing the Cary buildings that you have, but maybe you can describe if you have a partnership with Duke Energy and what might be going on with that.
Yeah. So we definitely work very closely with Duke Energy. I did want to mention that Emily Barrett, our sustainability manager, she helped. I was hoping she would co-present with me today, but she helped with the slides and stuff. And her and I work with Duke Energy. Obviously, from like a street lighting perspective, we don't own our lights or our poles. which is challenging. We did change out all of our poles to LEDs several years ago, so that was some energy savings. We'd like to get to where we get some controls on that. From a building standpoint, we're always working with Duke. That's kind of where the data analytics piece comes in. We provide reports to them and work with them on our rates and trying to reduce energy and cost on that. That's about all. That's about all I know on that. We're trying to do some testing, smart city testing on our campus. We have a lab on our campus that we test out smart city solutions. So we're trying to do some connected lighting tests with them. So we've been working to try to set that up. So.
Hi, I'm Susan Sanford with the Research Triangle Clean Tech Cluster. That was a great presentation, and I think describing, Jennifer mentioned it earlier, how you kind of tackle data silos internally at Town of Cary and streamline your systems to get you to where you are today. I guess what I would love to know is, how are you organized across the Town of Cary and your departments to sort of look at what's the next use case? Can you describe a little bit sort of
Yeah, so we have
prioritizing?
So we have a Smart Cities Committee. The other thing is I'm over our data management group. So when Jennifer was talking about data management, we're working on our plan to how we're going to handle that, how we're going to handle privacy and security and all that. But we have a Smart City Committee. It's 2 people on every department. We meet monthly. I mentioned the whole system of record exercise. Basically, we had a full half-day session where we just hammered out, everybody in the room, talking to all the people in their departments, finding out all of the different systems of record. And so that was our first task, and we've completed that task. And so then the next thing is really going in there and finding out what systems we need to consolidate, what systems are worth interconnecting. If you've got something, a platform or something that 2 people are using, am I going to spend my effort trying to connect that platform? Or am I going to spend the effort trying to connect to the building automation system that's going to affect everybody? So part of that group is to determine what our use cases are, and then do a test, interconnectivity and all that, to find out, is this going to work? Is it going to say what, we can do a use case, but is it going to achieve what what is the problem we're trying to solve? Is it going to achieve that problem? That's one of the hardest things I think with smart cities is identifying what is the measure of success, and then putting in the time to measure that. And then that's where the analytics comes in, is having that data showing that, it is successful, and then scaling it out. I mentioned that the Yates unit we put in, we put that in one building and we didn't know, is this going to work, or maybe we need a different solution. So, that's kind of how we approach it.
Thanks, Terry. That was great. Terrific. Well, in the same vein, we've got one more case study before we break for lunch, so don't fall asleep yet. And that is going to be Ram Sastry, who is speaking on energy management solutions for commercial buildings and industrial facilities. I just saw Ram earlier, where he's hiding somewhere. Oh, there he is. Good news.
Thank you. Thank you. Hi, everyone. I know I'm standing between you and lunch, but knowing Richard Soley and Kathy Walsh, the wonderful IIC folks, they saved the best for the last, I assure you that. So I'm going to talk about TCS's energy management solution for buildings, commercial buildings and industrial facilities. Oops. How do you? Oh, this. Okay, here you go. Is this the one or? Green, yeah, this is. Oh. Okay. Okay. Yeah, let me use the keyboard. Yeah, so building energy management, I'm sure, doesn't need any motivation. But as we all know, this is data from the International Energy Agency report and the Energy Information Administration. They consume 40% of the world's primary energy. They're responsible for a lot of, roughly 1/3 of greenhouse gas emissions. Growing electrification of energy, moving to a service-oriented economy. Amongst all service end-use sectors, certainly buildings still dominate energy and efficiency investment. And of course, there are a total of 5.56 million commercial buildings in the US, accounting for 18% of energy consumed. And as I think one of our previous speakers mentioned, the operating costs in running a building. We're talking about buildings and commercial, industrial facilities. So this really motivates the need for energy conservation, and that goes towards a reduction in the operating costs of a building. So I'm sure all of us in this room agree that energy conservation, this is good enough for motivation. So before I proceed, what I'm going to do is I'll play, with that motivation in mind, I would like to play a video. Why is this?
Today's enterprises have a need to optimize their energy needs and drive business growth without compromising on their eco-sustainability goals. Increasing energy prices, emission targets, and operation costs are all of which lead to several compelling reasons why you should monitor and control your energy consumption. However, businesses face challenges with energy management in the form of their massive scale and diverse infrastructure spread across geographies, little flexibility in deriving data from legacy and proprietary systems, generation of accurate real-time readings, and lack of real-time actionable insights. Today, digital technology can not only help you overcome these hurdles, but with the power of analytics, it can also identify your key energy consumers, highlight energy wastage, and give you predictability of demand, so that you can achieve real savings. Leveraging the concept of cognitive modeling and IoT, Tata Consultancy has designed the TCS Smart Energy Solution that gives you an enterprise-wide consolidated view into your energy consumption and enables you to take informed decisions through predictive analytics to maintain and improve assets and workforce utilization. No matter how complicated your infrastructure is, the TCS Remote Energy Management Solution, powered by edge devices and cloud technology, is a highly scalable and robust system which can be easily integrated into it. Providing you with usage trends across time and actionable alerts on ongoing anomalies, it works as a real-time decision support system for your organization. Its unique self-learning, self-optimizing feature enables it to configure and adapt to new buildings, new consumption patterns, outages, and new weather and occupancy patterns without human intervention. Tata Consultancy Services has already set an example in the industry, with more than 100 different sites spread across the entire geography of India, some of them more than 40 years old, 10,000 plus IoT sensors, and more than 1 million observations a day. The TCS Smart Energy Solution has helped TCS realize 10% savings in its energy use in the first 11 months of its deployment. And this entire setup is being monitored, managed and controlled centrally from the Remote Operations Center in TCS Kochi. The convergence between energy and digital technology is paving the way for a new ecosystem of services in smart enterprises, smart manufacturing, and smart cities. Giving you real-time insights, centralized operations control, and predictive analytics, the TCS Smart Energy Solution, backed by our cross-industry expertise and domain experience, is all that you need to achieve and exceed your energy goals, achieve real savings, and have a future-fit workplace. Digitalize your energy management and reimagine your operations with TCS Smart Energy Solution.
So, getting back to our, you can close it. Yeah. So now getting back to our presentation. So you heard that, you saw that video. I'm proud that leaving aside the TCS part of it, as you can see, energy management with Internet of Things, and you saw there a lot of things about IoT sensors, predictive analytics, the holy grail of IoT. I'll get into a little bit of that. So these are all the new digital technologies that were brought to bear in this energy management solution. So essentially what this involves is, you're seeing that round circle there. It's about sensing, monitoring, analysis, responding, and then retrain. Now, of course, the energy data can be coming from various sources within a building: chiller plants, room thermostats, occupancy sensors, so on and so forth. And of course, the key is this closed loop self-optimization. The idea is to gather all this data, do your predictive analytics, look for deviations in set points, look for how best to operate your equipment, look for energy wastage. Those are the things that are going to give you the savings and the reduction in the operating cost. I won't get into too much on the technical side of things, but this solution, any IoT solution for that matter, it has to be interoperable. It has to be able to communicate and gather data from a wide array of sensors and systems that talk different protocols, and that's what you see in the center of that circle. So moving on, so here is a rough. Now, I'm not going to get into, Richard is looking at me, I'm not going to get into the gory technical details of this architecture, but it follows the standard IIC, the reference architecture. You see on the left, you have your assets and your things, and in the middle, you have your other data sources, and including a gateway or a building automation system. Together, you can call this forming the fog, if you will, the edge and the fog. And then coming on to the back-end IoT platform, where you do all the analytics and then integrate with your back-end enterprise systems, as even you saw our previous speaker who was talking about integrating with the Salesforce cloud and other systems. So this is the rough technical architecture. I'm not going to speak too much about it, but suffice to say that what is important when you design an energy management solution, even today, you have to deal with legacy systems. You may have sensors that have direct connectivity into a back-end platform, or you've got to have some kind of a fog or an edge device that's going to gather all this data from these different protocols. And last but not the least, very important, is you need to interface with a building automation system, because most buildings are equipped with the building automation system. So that's where, or you can interface directly with a controller to get things like, as I said, temperature, flow rate of a chiller, inlet temperature, outlet temperature, chilled water temperature, and so on and so forth. Now, all that data is what is coming into the back end, and you're going to do some of your predictive analytics. Now, the predictive analytics can come in many forms. One is, many times you set certain set points, and if there is a deviation from that, you issue an alert. But the more interesting, the IoT analytics, is to do predictive analytics. So things like, a chiller plant in a building is a complex industrial machine. It has a lot of components, and looking for predictive maintenance of that particular chiller is very important. Now, one profound thing about building energy management, and in fact, predictive maintenance is something that I'd like to highlight and leave you with. You see, we are sitting in this building, and we're all comfortable. And most of the time, we do not complain as long as we're comfortable. But the point is, the chiller plant or your building or heating systems may not be operating efficiently. They may be doing a job of keeping us comfortable, but they may not be operating efficiently. Now, predictive analytics or anomaly detection and things like that are going to uncover those efficiencies. That in and of itself is very useful for a building automation, for a building manager to reduce operating costs. So I won't say too much more on the predictive analytics part, but this solution not only involves, there are different variants of it. It's not just electricity, but it's water, we call it wages, water, air, gas, electricity, and steam. And we also have, as you can see from that middle, and we have what's called, this is a managed service. So you can have multiple buildings spread throughout a geography, throughout a city. We just heard the previous presentation. You gather all this data to what's called a resource optimization center. That is where all the analytics, and you have even human experts looking at the data and making sense of it. It's man and machine working together. A little bit about our results. This is a wonderful case study. Again, I'm a consultant and I talk to clients all the time. Nothing better than you invent. I wouldn't advise, pharmaceutical doctors to do it. Nothing is better than testing something on yourself. So when we designed this solution, our CEO challenged us, and he said, implement it on our own buildings. We have tons of buildings. And you can see some of the statistics over there. I don't have time to go into all that. But 135 buildings and so on and so forth. And what I'm going to show you is the results. And this was all monitored through our resource optimization center. And very quickly, you'll see some of the results. You'll see 10% per annum energy reduction, 200,000 plus per year. It's enough. The amount of energy savings was enough to power 200,000 homes per 6 hours a day. And in a country like India, that's a significant savings. And of course, employee comfort. And of course, there was also 39,000 tons equivalent of carbon footprint reduction. Now, coming to SAS and not showing you plots and statistics, I wouldn't be doing justice. So here is some statistics over here. You can see that on the left side, you'll see the energy is steadily increasing, and that extrapolated. You see that it goes all the way up to that last blue dot on the right side. But then when we kicked in this system, you see that the energy savings kicked in and it relatively remains flat. And on the right side, this requires a little bit of explanation, but essentially what it is showing you is that despite the fact that the overall occupant area increased and the number of people sitting in a building increased, you still had significant reduction in energy consumption from the time the energy management solution was kicked in around 2014-15. And last but not the least, I'm going to leave this. I don't have time to talk about industrial facilities, but this is when it comes to industrial facilities, even in today's process industry or manufacturing industry, manufacturers want to do benchmarking. How did one plant do versus another? They also want to be able to dynamically predict what my set points for a particular asset should be in order to subject to it operating very efficiently. I'm a control engineer. All of us have known this notion of adaptive control, and that's where the analytics comes in. So you have a complex asset, you have its digital twin. Now you're trying to estimate the parameters of that asset and then use those estimated parameters to control the asset subject to it operating energy as efficiently as possible. So this solution, the analytics will help you do that by gathering all the data from the distributed control system in a plant. And that's what we're doing. We have implemented this in steel plants, for example, and in automotive plants. And we've got significant energy reductions. And the last but not the least, the main thing is about manufacturers, for example, want to get a fine-grained view into how their process is operating, which machine is consuming what energy. That in and of itself is a lot of information and leads to conservation measures. After all, don't mean to scare you just before lunch. If I were to go to lunch and I had a meter telling me how much cholesterol I'm taking, how much sugar I'm taking, can you imagine how many of you are going to have dessert if you were to do that? But with that, I'll close, and if there's time for a question, I'll take by all means. Please.
With the digital twins that you're using, are they based upon the building that you're trying to change, or using a reference model, the ideal model?
So can you repeat
the digital twins that you use for analytics when you're trying to do a comparison?
Yes.
Is that digital twin based upon an actual building, or is it made upon a fictional, idealized plant?
Oh, yes. No, yes, it's both. It is an actual building, but when it comes to a digital twin, it is more applicable, or at least what we have done, for industrial assets. For example, a boiler that produces steam to run a power plant. You have a digital twin of a boiler, which is the real asset, it's the real model of a digital twin, which then is populated with real-time data coming from the distributed control system, and then it lets you do all the wonderful analytics, predict its future finite horizon performance, the ability to predict estimate its parameters, set the right control using those parameters subject to minimum energy operation. So, yes. Thank you.
Thanks, Sven. That takes us directly into lunch. We're going to break now until 1:30. The lunch is downstairs. To get there, you go to the microgrid testbed demonstration. You go watch the microgrid demonstration. And then across the hall, you go downstairs to lunch. We'll start again at 1:30. We'll wrap up with a great panel moderated by, me. Thanks very much.